All right. I think we're live. Right.
Well,
Awesome. Cool. Well, so I would say welcome everyone to the 2024 edition Infosec Jupyterthon. I'm glad to see that a lot of people have shown the interest to join this conference. This started back in 2021, 2020. So I'm glad that over the years we have a lot of people that not only want to share their notebooks, but also want to, join us in the conversations and try to go through the whole 2 days. We started. The first conference actually started with a lot of different talks, so we were like almost like 6 hours or 8 hours, I think, one day. So this one is going to be a 2 days conference, and I'm actually here leading this effort at least for the first hour or two with with Ian, also from the Microsoft Security Research Team. I'm Roberto Rodriguez. I'm also part of the Security Research Team, and we have also a bunch of people that are helping us that will be joining us as we go along with all the different talks. So to kick this off, I put a couple of things in a Jupyter notebook that I would like to share, and also some housekeeping, trying to share information about the times, the links, the agenda, etc. So let me share my screen now, and let's see how we can do this. There you go. Okay, so this is the one. All right, cool. And I believe Ian, you can push me. There you go. All right. Thank you very much. So a couple of things in here going on. So this conference is actually backed by a couple of things. There is a GitHub repo. There is actually a Jupyter book, right? How you can take a bunch of Jupyter notebooks and make them HTML files, and then that could be a website, which is what you're seeing in here right now. And so if you go to the GitHub repo, this is the Infosec Jupyterthon, where we're going to be putting a lot of the slides or notebooks and just all the information that we use in order to build this conference. So if you want to take a look at that, that's one way to do it. Then we build this Jupyter book on the top of that GitHub repo. So you will see a lot of information in here, such as, for example, the agenda, right? You can go right to that. That's infosecjupyterthon.com, and you can just go through all the different things that are going to happen in the next 2 days, right? We also have, for I guess the second time this year, a speakers actually profiles views. So if you click on, for example, our keynote that is going to come in a couple minutes, right? You will be able. Oh, sorry, no, that was not a keynote. That was this one right here. There you go. Okay, so you can pretty much learn more about every single speaker that we have, because there is just some amazing bios that we can now just talk to them about like in 10 minutes or 5 minutes. And then you can also see all the different talks that they're going to be doing. So most of them, of course, have only one talk. So just make sure that you kind of bookmark some of these talks that you want to watch these next 2 days. And also remember that this is in Eastern time zone, right? So all these times in here. All right. So we're going to start also with a Jupyter notebook. And it is something that I put together to share a couple of more things. So once again, for those that are just joining us right now, so welcome to the Jupyterthon 2024. And something that I wanted to do was to share a couple of numbers based on all the people that register from across the world. And well, first, for those that don't know me, so I'm Cyberwar Dog in Twitter. And in general, I just love docs and open source in that specific order. And if you want to follow a lot of the research that I've done with the community, you can go to the OTRF GitHub organization. And something that I like to share also with the community a lot is something that is not technical. So if you go to Infosec Well Done, it's actually a site that is also backed by a GitHub repo, where we have a couple of people from the security industry sharing some of their favorite recipes, right? So you can see a lot of cooking in there. If you want to take some of those recipes, there is some Peruvian recipes as well. So now let's dive to some of these numbers for this conference, where the first thing is the industry. We did have around, oh, that one didn't play. Okay, well, we can actually troubleshoot this. Let me just cancel this. And that's what it was. Let me go to Jupyter Lab again. I don't know what happened in there, so let me just stamp this up again, and that should take us. Somehow it's not showing. So let's just go back to Jupyterthon. That's weird. Okay, well, let's use this then. So this is the same thing. It's good to have the all classic Jupyter notebook, available right away instead of using Jupyter Lab. So this is pretty much taking all the people that register and told us where they were actually joining us from, specific countries. And I just took that document. It's also part of the GitHub repo, so you can go to this data folder inside of the Docs 2024 folder in the GitHub repo, and there's all the information. Of course, the people that register their names and emails is not there, right? But it's just metadata of every single person that registered. And this code allows me then to pretty much show the number of people across different types of industries. And this is one for those that are beginners. It's just a way that you can actually start even practicing some of this, how a Jupyter notebook actually captures the input, it captures metadata like titles, descriptions, all the way to the output, right? And as you can see, we had at least almost like 600 people that register in this for these next 2 days. And technology seems to be the industry that is joining us the most. The second number is actually the notebooks experience across almost 600 people that register. Same idea. This is the input code. And at the end, this is something that we see every single year, which is the majority is actually beginners, right? And that's super important because I know that a lot of people that I talk to, actually ask me if I join the conference, I'm going to start looking into all these like advanced use cases so this is actually a way just to see how there is still a lot of people out there that are joining us that would love to learn. So we'd love to learn about Jupyter notebooks from a beginning level. So for speakers that are joining us this day and today and tomorrow, just keep that in mind, right? When you talk about your presentations. And the expectation, so this is a cloud, word cloud. So we just took all the expectation comments from the registration, and these are the topics, right? Security, using Jupyter notebooks, threat hunting, data, etc. So another way to be able to visualize some of your information. This is just more information that I shared already, right? Everything about today and tomorrow, and all the links are also in this notebook. And this is part of our website as well, so you can get all that information right away. And the last thing is we wanted to see the community that is joining us for the next 2 days. And this is amazing, right? We go from, I think the majority is from the US, I would assume, in here. And 226 people. But it's just amazing to start seeing people from Mexico, Guatemala, there's Dominican Republic, Venezuela, Colombia, Brazil. We go to Europe. There's just a lot of people from like all over the world, right? I actually learned about some new places in here as well. So this is amazing to see the community that is joining us for the next 2 days. I hope that you enjoy all the talks. There is just some amazing, it's actually amazing people that are going to be talking about some of their experiences with notebooks. Most of the talks are going to be 15 minutes to 30 minutes. So I think that hopefully that format also helps you to stay engaged, right? And that's it from me. So we can just then go back to the studio and we can start our first talk of the day, our keynote.
Hey, thanks, Roberto. That was one of the problems of having notebooks open in 2 tabs at once. They keep overwriting each other.
Yes. yes. I forgot about it. I was testing the classic view and the Jupyter Lab view and try to pick what was the best view. And yes, but I love to always go back to what actually works, at least in this case, most of the time, right? So yeah, that's nice.
Didn't do VS Code. You have 3 conflicts.
Yes, I actually do have VS Code open, so that might have been true. All right, so
cool.
We have Ryan joining us, right?
Yep. So I'm going to add Ryan onto the stage. So welcome, Ryan. I've
hello
known Ryan for quite a while. He did an amazing talk at last year's Jupyter, well, the 2022 Jupyterthon on the use of magics, really innovative use of magics in notebooks. So if you haven't seen that, I would urge you to go back and check last year's recording on YouTube. Ryan is, works with SecureWorks, and they've built a kind of industrial scale threat management, threat analysis system based on Jupyter notebooks. So I'm very excited to hear about this. He's also a contributor, something close to my heart, to Mystic Pi, which is a kind of Infosec Python kind of Jupyter notebook library, which I've been working on for the last 5 or 6 years, I guess, something like that. So it's really nice to have Ryan helping out with that. So without any further ado, I'll hand over to Ryan, and you can presentation on, and I'll disappear into the background.
All right. Thank you very much. It's an honor to kick off the conference. I'm really excited with the talks we have coming up, and I'm sure everyone's going to have a great time. I'm here today to talk about barn raising. So we're going to start with an analogy. Imagine that you're a farmer, and that means you probably need a barn. And as a farmer, you have many different skills, but you probably don't have all the skills or resources or time to build your own barn. If you're a lucky farmer and you live inside of a community, that community might collectively have not only the necessary skills and resources to build a barn, but also the willingness to help you build your barn. And in some parts of the world, this is called a barn raising, when the whole neighborhood shows up to put up this structure. And it makes you wonder, like, what motivates communities to do these like seemingly selfless actions, right? Helping their neighbors build their barns. But ultimately, it kind of boils down to the fact that it's an investment in the collective future. And I think that the barn raising is a good analogy for the kind of community that we've developed at SecureWorks, the community of Jupyter Notebook users in particular. And I wanted to use this talk as an opportunity to give a retrospective on how that community came to be. And, the purpose in sharing this is hopefully there are some lessons learned that you can take away and bring to your organization if you're also trying to grow a similar community of notebook users. So over the next about 30 minutes or so, we're going to go look back in time, and we're going to focus on notebook adoption at SecureWorks, and in particular focus on what the key drivers of growth were for different periods in our sort of journey of using notebooks and growing this community. In particular, we're going to be looking at who were the users, right, at different phases of this journey. What were they using the notebooks for, and what problems did they run into? What were the solutions they came across, and how did they measure success? But ultimately, with the benefit of a lot of hindsight, we can look back and come up with what were the common themes that really defined these periods of adoption, and what can we take away from that? So our story starts here, the innovators who are our DFIR consultants. So the life of a consultant is going from engagement to engagement for different customers, each of which has different success criteria. And you might have anywhere between 40 hours to 500 hours. And at the end of this, hopefully you've solved the customer's problem and you deliver to them some long form written report that explains what you did in the case of a forensic investigation. All of these engagements are also really high touch, and consultants are actively encouraged to get creative and do anything it takes to solve the customer's problem, right? The most successful consultants are often the most creative ones who are self-reliant. But the self-reliance element kind of has a side effect, which is that for different consultants, for different engagements, we tend to deliver things differently. So our journey in Jupyter Notebooks actually started without thinking about Jupyter Notebooks at all. What we really wanted to do was consolidate basically process guides or procedures that different consultants would use to deliver their engagements. And these were scattered all over our internal intranet, in wikis, in training, in docs, in PowerPoint. And there was no review process for any of this. And ultimately, right, these were just written guides. This is how you do this task, right? Mount this drive with this kit, do these things, X, Y, Z. So our first task was consolidating these all together and just putting them under version control. And we decided to sort of encode these procedures in Markdown because it's very simple, it's easy to use, easy to read, right? and we just stuck them all in Git. And that was great. But ultimately, having all these processes centralized is not really adding a whole lot, right? These are still very manual processes. And we kind of thought, what if we could automate these? Like literally inside this part of this markdown description, what if we then went and had the code that did the thing that it was telling you to do as the consultant? And I think it was this proximity of, the very nice descriptive written language alongside potentially, the blocks or cells of code that are doing the stuff that language is describing. That's when the light bulb kind of came on that this might be a really good use case for Jupyter notebooks, right? Because you have those code cells and markdown cells. So we chose a project called Jupytext, which is very central to a lot of what we do here. And it's a really wonderful project that lets you actually write your notebooks as just markdown documents rather than their JSON format that you're familiar with, like an IPyNB file. The side benefit of this is it's very easy to collaborate on, easy to edit. It's just a markdown file, but at runtime, you can take that markdown file and use Jupytext to magically turn this into a living, breathing, executable notebook. So that's kind of where this all started. We started jamming some code into the markdown and using Jupytext to structure it. But when it came time to actually use those procedures as notebooks, it was very clumsy, right? So if you wanted to use one, you had to check out a version control, convert it over into the notebook, and then actually run it. And it was really clumsy, and people just were not fans of how it worked. So one of the big changes that we did was we embraced the fact that Jupyter notebooks support GUI widget elements in the rendered notebook to create little miniature user interfaces for common tasks that users would do all the time. In particular, we use these to abstract away some of the underlying Git plumbing. So users could simply, with a couple of clicks, synchronize repos to pull down the notebooks, inject parameters, select the customers they want to apply, etc. And we chose a project called IPyVuetify to do this, which is a wrapper for Vue.js, which is a really wonderful component library. So we could write this all in Python, but have a nice, pretty interface. And I realize this is probably hard to see, but the idea is that we would have these sort of steppers or modals that would basically take the user from clicking and syncing my repo full of these different notebooks, selecting which one in particular you want to run, getting some other input from them, and then you just get a link. Boom, you're off to the races. Over time, the content of those notebooks, though, got really, really ugly because it just was like the spaghetti code where there's a lot of repetition and everything was very bespoke, right? For any type of connecting to a different API, all that logic kind of lived in that notebook. And the kind of elegant, nicely readable procedures get lost in this mix. So we knew that we needed to do something to declutter the notebooks and actually start taking more seriously the sort of shared library of functionality that any notebook user would probably want. And probably the most emblematic thing that we came up with that does this was our embrace of IPython magics. As Ian mentioned, I did a talk on this in a previous Jupyterthon, which you should check out if you want to learn more about it. But the long and short of it is you get this sort of nice macro-like syntax where you can query some external system, so a database, in your EDR tool, and then we'd bring back the results and we turn them into data frames, pandas data frames for you automatically. So it's this kind of convention that really cleaned up the notebooks. You could read them really cleanly, and you could get back the data that we cared about in the format that we wanted them to be in, ultimately. So when we started in this innovators phase, we went from procedures being scattered all over the place and purely manual to being centralized in version control, and then also partially automated by having them in the form of Jupyter notebooks. When we talk about some of the outcomes, we got better utilization rates and generally more consistent delivery. And all in all, it seemed like this idea had legs. We could do something with this. And when I look back in hindsight, the whole theme for this period to me was lowering the bar to entry. Anything that would be in the way between the consultant and getting up and running and productive in the notebook was something we had to kind of sand off and get them up and running as quickly as we could. So next, we're going to look at our early adopters, who were our security analysts. And the conversation kind of went like this. Folks from our security operations side looked at what we were doing in consulting and said, hey, this looks really nice. Like, can we kind of get in on some of this action? And can you help us get started? And since we're good members of this community, we wanted to help them raise their bar. Very quickly after speaking with the security analysts, we realized that they have very, very different needs than the consultants did, right? Analysts generally work in larger, more mature teams. They have established processes and existing automations in place in a way that we just didn't on the consulting side. And we need to think very carefully about how the notebooks would fit in and deconflict or otherwise integrate with their existing automation. Security analysts also are generally under very different time constraints than consultants, where they may only have something like 1 hour to do some sort of task rather than 100 hours where they could possibly write a whole bespoke new tool to complete their objective. And then lastly, the way that we would take the outputs from that notebook and deliver it to a customer was also radically different. So instead of big, long papers you would send to a legal department at the conclusion of your investigation, we're talking about populating the contents of tickets or investigations in our XDR platform. So there were definitely growing pains during this process. And the way we kind of approached it was we picked like a small, a handpicked number of champions on the security analysis side who we could mentor and provide a whole lot of support to, right? Smother them with love. They know their use cases way better than we do. And we wanted to make sure that we could help them with what we knew about the notebook side and come to something that would work for both of us. So the champions was a huge part of it. Having an open door policy around chat where anyone from any of the teams that we're going to discuss today could pop in, ask a question, right, was really important to know, to let people think and feel that they have a support network and that as they run across issues and using these notebooks, which they absolutely will and do, there are other people who are willing to help, right, which is very important. Roberto also already mentioned JupyterBook, which we also use and love quite a lot. It's a really fantastic project. We would use JupyterBook to create interactive training that we could do hands-on with security analysts to get them up and running. And then you have the nice side benefit of it looks quite nice as a static site for rendering it as a form of reference in the future. So the original project design had all of the notebook content, the magics, the Jupytex stuff, all that plumbing was really in just one big mono repository. And it became very obvious when we started working with the security analysts that this was not going to work. When they wanted to make a change to one of their notebooks, someone on, sort of on our side who were the maintainers of that repo would have to do approvals, for example. And it really clouded up our Git history. It's very hard to tell what changes were just for content and what changes were to actual code. So the next step in our maturity was to break apart the monorepo and into a new project structure. And we use GitLab for our version control system. And basically, we put each of these different teams that were going to use the notebooks into their own groups. And we were able to use the built-in RBAC functionality in GitLab. So that way, that team had their own approvers to go through their own review processes and merge in their own changes. Whereas sort of the core maintainers of some of the notebook plumbing, we could be separate, right, and not have to worry about us being kind of gatekeepers or moderators for their code. And also importantly, we provided some centralized CI services in the form of tests and linters, so that each team could write little linters that say, for our team, we want our notebooks to have this structure. Right. And if you try to commit a change where that notebook doesn't have that structure, it would fail to merge in. Right. It would throw an error. But it could be a different structure than another team. So we weren't trying to enforce any type of standards across everybody because every team had their own unique needs and requirements. Okay, so this one's a doozy. Anyone on this call who's done anything in Python before knows that Python package management is a nightmare. So by far, our biggest burden from a support perspective was troubleshooting environments, right? Everyone would really run a lot of this code locally on their like forensic workstation or whatever. And there would be often sort of disparities in terms of the versions that they were running. So people would report bugs for stuff we've already fixed. We had no way to sort of be consistent in this experience for using the notebooks in a way that would scale. So there were two sort of solutions that came along with this problem. The first was finding a common form of infrastructure that we could run the notebooks on. And in our case, the tools that were available were AWS SageMaker is a hosted notebook service where effectively every security analyst and consultant has a dedicated EC2 instance that runs Jupyter and is partially managed by the cloud provider. But we could then, rely on the fact that we know what version of the operating system it's going to be. We know the file system structure. So if we want to automate or script something out, we kind of had a reliable target environment for us to deploy whatever the notebook code was going to be. And then secondly, again, there were a lot of issues with version and version management. So just because you're running on the same type of EC2 instance doesn't mean that everyone's running the same version at the same time. So we embraced this functionality in Python. It's not really super popular or well-known, but it's called a zip app. And effectively what you can do is you think of it like a virtual environment that you zip up. And we would build that environment in the CI pipeline, and then we would simply upload the built zip app to S3, where all of those SageMaker EC2 instances could pull down the newest version on demand. And that was our sort of continuous deployment method of ensuring that everyone who was using sort of our toolkit was running the same versions, and it could be consistent and reliable and otherwise stable, right? Which is really important. So we chose LinkedIn's Shiv project, which is just an implementation of zip app for this, and we've had really great luck with it. So up until this point, whenever we mentioned, hey, a human ran a notebook, that was literal. A human had to go to that little playbook or notebook selector I showed you before, plug in those parameters and then run it and then do something with that output. And it was very clear as well that if we wanted to do some sort of task at scale across every single customer in an environment, for example, then we would either need a whole lot of people, which is not often possible, or we'd have to come up with a better, more clever way to scale out parallel and not human-driven execution of the Jupyter notebooks. So that's pretty much kind of what we did here. We took the same environment effectively that you would have running in SageMaker that we were building that zip app for, and we would instead create a Lambda function with that same runtime on it that's simply listening from an SQS queue. So we could say, hey, I want to run this notebook against these 700 customers, and you could set the parallelism threshold, and it would run it in the Lambda function without a human having to click anything or do anything. Whatever the results were that you would pull back from your queries in your notebook, those would get cached and stored back into S3 for analysis later. And then we had the ability to look at all of the notebooks for all of the customers that we ran it for in aggregate to look for ones that were actually worth further analysis and which ones we could say, lack of evidence, for example, we don't need to escalate further. And even though we were using Papermill from the very beginning, this is where Papermill really, really shines, right? You can just take a notebook, take these sort of parameters and inject those into the start of it, and then, off to the races. All right, so when we think about the early adopters period, the key outcomes were, well, I think from management's perspective, notebooks went from, these are useful for like individuals to like, if the notebooks blinked out of existence tomorrow, we would have a hard time meeting our obligations, right? We are baking in this capability and improvement into some of our SLAs. So it became really important for the team in kind of a inadvertent kind of way. And if we look at, again, the themes, this is 3 ways to kind of reframe the same basic idea. But like in the early adopter phase, we had way more effort spent on the non-code, non-technical parts of managing this project than we did on the actual implementation. So it's about, the being available to help with chat, putting together documentation, coming up with good guidance, the care for those champions. Scaling can be hard, right? But I think the way that we did it, we kind of ran it like an open source project, but just internal to our company. Worked out really, really well. And we were able to kind of get through to the point where the security analysts were comfortable enough with it. They didn't need our hand-holding quite as often. All right, next we're going to look at the pragmatists, who are the security engineers. So unlike the consultants and the security analysts, when we talk about security engineers using notebooks, these folks are already full-time and experienced software developers, first and foremost, right? They're not, obviously consultants and security analysts are very technical, but they're not developers necessarily. So if the engineers that were using Jupyter kind of generally boiled down to kind of two ways in which they would use it. Some, like our data science friends, were already using Jupyter notebooks, but primarily to prototype new features that ultimately would be implemented outside of the notebook, right? And then for those who weren't necessarily using Jupyter directly, would come in contact with them whenever we would open up a bug report and attach a notebook as evidence, right? Something that's reproducible. So between those different ways, the engineers caught wind that, hey, we have this Jupyter Notebook kind of toolkit, and maybe there's something there that would benefit them. So almost everything we did in the previous sort of two phases to make life easier for consultants and security analysts made the security engineers' life harder. It was the complete opposite in terms of what they were looking for in a Jupyter Notebook kind of toolkit. So they didn't really want to use our big turnkey notebook runtime. They wanted to kind of cherry pick specific libraries or modules to include for, using building on them in other ways, right? So they wanted a developer experience, and we were really, really focusing on an analyst experience. And the solution was effectively to kind of unbundle a lot of the components that we had put together and make sure they were available in all of the places that those software developers were already working, right? So push them into the package registries and GitLab, the container registries, artifact buckets. We went ahead and finished what we called the doc stringing, which was adding all the doc strings and generating code for everything, docs for everything. Those were big steps to show to our engineering colleagues that, it may not have started as a project written by developers, but there's some really good fundamentals here that they could leverage. And they did. So I think this was kind of the turning point for our use of Jupyter at SecureWorks. Up until this point, notebooks, while used extensively, were always sort of reactive by nature. Like a human had to get some task assigned to them somehow, and they reached for the appropriate notebook to do the job, and then they reported it to a customer, right? What the security engineers here figured out was that, we could probably have a really big impact if we could set up the automated execution of these notebooks as part of our security orchestration system. So effectively imagine an alert is generated of a certain kind, and we have a notebook that's dedicated to triaging and understanding how to investigate that specific alert. Well, instead of assigning it to the analyst who then goes to get that notebook, we run the notebook immediately right away. And then when the analyst is actually ready to do the work, they already have this notebook in front of them, pre-populated with the relevant data, everything kind of ready to go for them to make a decision on whether or not they want to escalate to a customer or not. So it's a really, really big impact for us. So yeah, the significant improvements that we were seeing is in our what we call our time to notify metrics. Effectively, by having these doing these notebooks sort of as the alerts came in, having them ready to go, we were giving our security analysts the tools they needed to make faster decisions, and that ultimately was what we were hoping for. So again, looking back at the themes, I think the thing that stands out to me is that notebooks are an escape hatch. And we can use those notebooks to prototype new features, and automations really, really quickly. And maybe those go on to be full-fledged product features that are outside of the notebook, or maybe they can actually just function as notebooks too. And our last group that we're going to look at today are the adoption conservatives. And we're going to talk about what it's like trying to get notebooks in the hands of customers. So the conservatives here aren't actually the customers, it is our sort of product managers. So if you think about what a product manager does, they may or may not have a technical background. They might really not understand what Jupyter does or why it's useful. It's not really clear how it fits into some of their strategy or marketing. But one thing that all product managers are trained and are very good at is listening to customer feedback, right? Listen to what the customers are asking for and try to figure out how we can support that. And that's exactly what happened. So when customers would come back to us and say, hey, we're seeing these investigations that you're opening. You're clearly making them with some internal tools. We want to hunt like you do. How do we do this? So the product managers, we're talking to the customer. Then the product managers talk to the engineers talk to the analysts talk to the consultants. I think you see where this is going. And ultimately we said, we have these internal tools, but that's not very satisfying for a customer, for it to be an internal thing. Sorry, you can't do this. So this pressure from customers to say, we want to do things in the way that you do them, was a big driver for getting investment and support behind our open source initiatives to take a lot of the plumbing that we were using for this Jupyter Notebook ecosystem and putting it out in the public and meant for customers to consume from the very beginning. So you can check out some of the links that are in there if you want some examples, especially the Tejas Magic is a really, really awesome project. But this result is really only because of customers seeing the outputs from the notebooks and then asking for a similar capability. And it's like we're super, super proud to be able to put some of that stuff out there into the hands of customers. So as far as outcomes go, well, we're still in this phase. So we're still collecting those metrics and such. Ultimately, the type of things that would be a measurement of success would be customer engagement and adoption, stars on our GitHub, open issues, all those sorts of things, which we're actively looking for. And, we know that these tools were useful for us, which gives us really good reason to believe that these are going to be useful for customers too. So the theme of all of this, which goes all the way back to sort of the very beginning, was, I forget what film it's from, but if you build it, they will come. We're at that point now where I really hope that customers will also start benefiting from a lot of the work and collaboration that we did over this growth journey over the last several years. So back to the barn. Like I said, each of these phase transitions where, the consultants were using stuff and then the security analysts and then the engineers, every other one of these sort of personas or teams showed up to help. How can we bring our skills, our expertise in using these tools to bear to help solve your problem? And I'm just really profoundly pleased and happy to see that community. So there's a bunch of acknowledgements here that I really wanted to call out, because if you think of these like sort of the village elders, right? The people that really were holding the community together. So Micah Pegman in particular for the authoring of the Tejas SDK, the primary author of the Magics and so many of the other internal tools, along with Joe Messenger, kind of the three of us were a lot of the development effort behind some of the plumbing. And then Robert Hyam and Kevin Strickland, who were absolutely key to the sort of community management component of reaching out to those sister teams, getting time with them to understand the problem, seeing how we can help. Without these folks, this community would not have lasted and come together in the way it did. So that's kind of a whirlwind tour of the last several years of my professional life and effort. But again, we couldn't do it without Jupyter, and I'm confident that I hope you find similar success at your organization as well. And yeah, that's going to be that. Do we have any time for Q&A, Roberto?
I'm not sure Roberto's here to answer that question, but I think we do. Yeah, that was awesome. Thank you, Ryan. I'm sorry we don't have any a way to convey applause from the YouTube live stream back, but I thought it was fascinating, and I know a little bit about it already, so I've always been in awe of all the stuff you've done. We have a question in the Discord channel. Actually, I should pop this. So I think maybe I'll talk about this in a minute, but some people I think are having problems joining the Discord channel. But you can also add questions to the YouTube channel, and I'll try and monitor that as well. The first question we had, I've got a question as well, was about parallelism with Papermill. And do you do like Mika's like partly answered this, I think, or maybe answered this, but it'd be interested to get your point of view as well. Do you do kind of like parallel processing of notebooks, or how do you handle the scale?
Mm-hmm. Yeah, so you have two levers of parallelism that you can play with here. The first is for each serverless function, how many parallel notebooks do you want to run in that function? And your primary limitation is going to be the memory available for, because it is shared among all the notebooks that are executing, right? So if you have big result sets, you can't really run that many in parallel. Also the time, because most of the serverless functions only last about 15 minutes before they time out. So generally for those, we actually just did individual execution, one notebook per invocation of a serverless function. But our parallelism came from the fact that you can scale up those functions. So we had a queue that would have, set parallelism of 16. So it would basically make sure that there are always 16 functions running at any given point in time, each of which would run one of those notebooks.
Cool. I had a couple of questions. Just going to check if there's anything. Right. Sorry, I'm trying to monitor the chat discussion. So I'm just kind of wondering, like, how the like, having worked in notebooks for quite a long time, and I've talked to many organizations that are interested in kind of implementing them at some scale, but often there's like suspicion about Python or notebooks, like difficult to manage, package management, stuff like that. Did you have a bit of a problem kind of convincing like senior management this was the right thing to do, or was it more a case that you demonstrated, look, this is really cool, it works, we're kind of doing it already? How did you approach that?
I think that's part of why this trajectory from going from consultants into the security analysts and it being a very grassroots driven thing, or it wasn't like management never came to us and said, thou shalt use notebooks to do this. It was, we were told, here's the problem, go do it through any means necessary. And we came up with ways that would work really well for us as analysts or as researchers. And in particular, the lingua franca for security is Python. So it really isn't a matter of performance or stability. It's about what people are comfortable reading and writing and all the ecosystem of things that we can benefit from leveraging, right? So it was a no-brainer for us. And obviously, as we basically became upstream dependencies and other stuff, we added appropriately more and more constraints and proper software development discipline around those to try to make up for it. But no, in general, I think that the Python choice was the right one from the beginning, and I don't think any alternative would have been successful.
Cool. I think we're just about at the end of the Q&A. I don't see anything. Just monitoring multiple kind of streams here. Don't see anything. But that was fantastic, Ryan. It's like I think it's a really inspiring thing for people like me who've tried to get buy-in from large scale use of Jupyter notebooks. Like what is the appeal? I think that's the key thing, that if you're in Infosec and you do a bit of programming, you're likely to be using Python, and it's the same with kind of data science research. So if you can do something that creates an environment where people feel comfortable, be able to like develop, like write their logic very easily, in a very visible way, and like it makes notebooks a very appealing thing for that community, without having to dig into like C# or even more friendly languages like Rust.
Mm-hmm. Yeah, we tried to give tools that would, if used, would have save common foot gun scenarios, right? Don't re-implement everything, right? We're going to give you this toolkit, and if you find a problem, like, we're going to fix it, and you don't have to worry about that moving forward. And that kind of snowball effect of built that reliability and trust in how the tools work, which is really, really important. And again, having the open channel communication, so if people find issues or bugs, they know who to come to. And we were very, very fast about bug fixes and pushing out, cutting new releases and stuff. So you got to build that trust with the users ultimately.
Cool. Okay, well, thank you so much, Ryan. That was just fantastic.
Thanks for having me. This was awesome.
Yeah. And we're going to have like a short break, and then we'll be back in a bit under 5 minutes with Colin Cowie. Okay.
Bye, everybody.
See you in a moment.
Enjoy the show.
Just a bit of an interruption to the music just before we get started. Some people have been having trouble, I think, joining the Discord channel. So just quickly, when you follow that link, you should get taken to a Discord, like a private or like a enclosed area that asks you to accept the code of conduct. And in order to accept it, you need to click on the 100 emoji beneath the conduct, beneath the kind of last question. That should then add you and open up the visible channels to you. So you want to join the channel Jupyterthon to ask questions. Typically, we'll have threads within that channel for each Q&A session. So feel free to ask questions. You can also use the YouTube thing, but that's a bit trickier for us to monitor. So I'll add Colin. Hey, welcome, Colin. So Colin, I think I'm right. I think Roberto was going to be introducing this, but he's had to rush off for something. So a hasty introduction. Let me stop the music. So welcome, Colin. Colin's going to be talking about one of my favorite subjects, kind of visualization of data, and using that in kind of forensic and infosec analysis. Colin's from Sophos. I think he's going to be giving us an introduction that's more competent than mine. So if everything's ready to go, Colin, then please take it away. I'm excited to hear this.
We'll go ahead and get started. This talk will be 20 minutes long and it will be recorded. Today we'll be talking about graphing ransomware and data leak site trends using Plotly. Just a brief introduction. I'm Colin. I work for Sophos. I've been with Sophos since 2020. I'm a part of our managed detection and response service. Outside of information security, I enjoy biking as well as stand-up paddleboarding, sometimes doing both on the same outing. And then I've also linked my social media on Mastodon as well as my personal blog and GitHub links. Let's go ahead and dive into the content. First, let me introduce Plotly. Plotly has been around for 11 years. It's open source. It's under the MIT license, and it has quite a bit of support for both Jupyter Notebook as well as Jupyter Lab integrations. As you can see, there are a lot of different graph formats available for Plotly. I think in general, it's more commonly used for statistics and data analytics. I personally started learning about Plotly a little over a year ago, and shortly after learning about that, I attended last year's Jupyterthon, and I'd heard about Jupyter Notebooks, but I hadn't really taken the time to start learning, and I was really impressed by the conference last year, and so I spent a lot of time over the past calendar year learning a lot more about Jupyter Notebook, implementing it in my work environment, and developing additional tools that help with my day-to-day job, which is mostly with investigating ransomware threat actors, looking at what kind of different intrusions we're dealing with our Sophos customers, as well as looking at the overall threat landscape as it pertains to ransomwares and data leak sites that they use to extort victims of ransomware. And so today's presentation is really highlighting one of my most successful and useful notebooks that I've developed over the past year, as well as talking about why I really love to use Plotly as a data visualization library as opposed to other alternatives. So first, I wanted to talk about where we get that data from. There's an open source project called Ransom Watch that's free, and it's on GitHub. And what they do is they monitor and scrape data leak sites that are on Tor, the Onion network. And these are sites where cyber criminals are attempting to extort victims of intrusions who have typically had their files encrypted through ransomware and stolen and exfiltrated out the network. You'll hear me use the term data leak site or DLS as opposed to like a ransomware leak site. And the reason why I do that is because some of these sites, some of the threat actors that operate these sites actually don't encrypt data. Some of them just do data theft extortion, where they break into people's networks, steal sensitive information, and then extort those entities for Bitcoin or Monero, whatever cryptocurrency that criminal prefers. And it's important to note that cyber criminals, like other corporate entities, also have metrics, and they want to be the best or the number one. And so some cyber criminals are known to inflate their stats or post stuff on their data leak site that doesn't necessarily equate to a full successful intrusion. And so you'll see a lot of graphics throughout this presentation about different ransomware groups. And it's important to remember that we can't take everything that these criminals put out there at face value, but we can still leverage the data from Ransom Watch to get a good understanding about which groups are posting the most frequently on Tor. And so within my Jupyter Notebook, the first thing that I do is download the data directly from GitHub. One of the reasons why I really like Jupyter and why I prefer using Jupyter as opposed to just a direct Python script is that you don't have to re-download the data every time you want to make one minor change to the graph. Another reason I like Jupyter Notebook, as it was mentioned in the last presentation, is that it does support graphical user interface options. Particularly, I personally like IPY widgets. And in this case, I've leveraged IPY widgets to provide a date input of just the past number of days to filter the data from Ransom Watch. By default, it's set to just one calendar year. After downloading that data and setting the input through the IPY widget, the next step of my notebook is to then prepare the data frame, look at that provided input, filter down the days, and then it's already ready. And if I want to change my graph format, I don't have to reprocess this. I can just make one minor change. Right away, before we start diving into some of the customization, here's just a look at some of the data from Ransom Watch over the past calendar year. As you can see, this isn't really the greatest graphic. It's a little bit hard to read. It might even be a little bit blurry. And a lot of people on this call are cybersecurity researchers, and everyone loves dark mode. So the next step here is going to be defining a custom theme that we can leverage to kind of create unique branding around our Plotly graphics and improve the quality of these outputs. And before I show you that custom theme, I wanted to explicitly mention that Plotly does support zooming in and having user interaction. This can be really helpful for actually investigating the data directly in your Jupyter notebook. So as you can see from these two slides, this is the initial figure. Then we can use the mouse and select in and zoom in, as well as look at hover data to get some more specific details about entries on that figure. Moving on to the customization. The technique that I've preferred in my Jupyter notebooks is to define a custom theme. I like to base it off the Plotly dark theme. It's also important to note that there's a button to export these graphs as an image, and you can customize the dimensions and scale of the figure when you run that export button in the Plotly figure. I personally like to increase mine by 2 to 3 times in scale, as I find that helps improve the resolution. There's also support for PNG, SVG, JPEG, and a few other file formats. From there, in my custom function, I like to set up a font, whether that's related to your organization, or in this case, I've decided just to go with Roboto. And then there's an option called paper background color, and that's kind of not directly behind the graph, but a little bit further, and I'll show you what that looks like here in a moment. But after we define that custom theme function, as you can see in the lower half of the slide, it's really easy to create a new graph. You just run it under px.scatter to create a scatter graph. Px is Plotly Express. It's like a library that allows you to create Plotly graphics very easily through the Plotly Foundation, which, as I mentioned earlier, has been around for 10 years. And in my function, I run fig.show, which actually displays that figure. And so here is what it looks like of using that custom theme. And as you noticed, the graph is using the Plotly dark theme as default, as well as with a custom font and a custom paper background. This already looks a lot better and could be more in line with your branding that you're desired. Another graphing format in Plotly that I find is really useful for investigating bigger data is density heat maps. The scatter graphs are interesting, but under large data sets, it's hard to actually visualize and understand some of the trends. Density heat maps are great for looking at a large set of data over time and being able to leverage the different Plotly continuous color scales is a really fun way to experiment with some different graphic options. The one on the right is using the thermal continuous color scale. There's quite a bit of different options. I think there's over 80 different color scales. You can also define your own ones as well. So a lot of options there. And just looking at this graph, you can see some trends right away. Noticeably, Lockbit3 has been very consistent with posting on their data leak site throughout the past calendar year. And then interestingly enough, Clop has some big spikes in their posting, which I think correlates to some of their previous threat campaigns that exploited externally facing devices such as MoveIt and in the early parts of last year. Another Plotly graphing format that I find really useful is just the simple bar graph. Here's looking at the reds color scale. This is just leveraging that same data preparation as before with some additional sorting to sort by the most frequently observed. You can have this on the right or the left. Plotly supports a lot of different customization options here. This is also filtered down to just the top 25 data leak sites, as there are there's a lot, they come and go. It doesn't look great with hundreds of groups on there. So this graphic is filtered down to just the top 25. And these graphic formats can definitely be useful for understanding the ransomware data leak site landscape as a whole, but there are certain situations where we might want to break down just one specific group or multiple groups and do some comparisons. And so what I've established as a method for doing this is leveraging a text area widget from IPY widgets that allows you to input multiple group names in new lines and then create a bar graph that displays those groups over time with different unique colors for each group. Here is one example comparing Vice Society versus Recida. Vice Society is a ransomware as a service that disappeared in the middle of last year. Resida ransomware is also a ransomware as a service that has some technical overlap between Vice Society, and some security researchers have theorized that the criminals behind Vice Society have shut down their operations and rebranded as Resida, even though they are the same individuals operating and carrying out those intrusions. To investigate that claim, I've employed Plotly with Ransom Watch data to graph both the monthly aggregation as well as the weekly aggregation to compare the number of posts to those data leak sites per week or per month. And as you can see, it pretty much cuts off from Vice Society and switches to Resida in the same month. And so this kind of comparison can be useful for investigating public research and claims about ransomware groups rebranding, which is a common tactic that these different ransomware as a service groups leverage to either throw off law enforcement, confuse security researchers like ourselves, or in some cases just to potentially switch things up and have a better or more professional looking criminal organization or data leak site. Another ransomware as a service family that has been publicly reported as rebranding is Royal ransomware. It was reported that they have now switched to Black Suit, and by leveraging that same code, we can do some comparison and look at some of the posting. And while this evidence is great, it shouldn't be used as the only source of evidence that a group has rebranded into a new group, but it certainly helps us with some additional evidence that we can use to correlate and improve our confidence levels around some of these hypotheses about potential group rebrandings. And I mentioned that this can't be used as the only method for identifying group rebranding. I wanted to graph just a few different popular ransomware families. There is an article on the Sophos News blog that was released last year about a cluster of activity that we observed, or we call it a threat activity cluster, where we observed the same tools, tactics, and procedures being leveraged to deploy ransomware. However, the final ransomware that was deployed changed by intrusion. We saw them on Hive in January, then they switched to Royal, then they switched to Basta, and then back to Royal before ultimately starting to deploy Cactus ransomware. And while every single one of those ransomware families leverages a different data leak site based on our investigation, and you can read this on the Sophos News blog, we identified some overlap in the affiliate behavior that was leveraged before ransomware. And so by graphing all four of these families, we can start to make some more assessments about the activity that we observed, as well as the nature of the data leak sites and the criminal enterprises. Particularly, one conclusion that we can come to is that although we observed this one affiliate switching to Cactus, there are still other affiliates that are still posting onto the Basta data leak site, which leads us to believe that it's potentially a larger ransomware as a service program. And I know this has been a really quick presentation, but I wanted to make sure that we allocated some time for questions, as well as showing this little meme here that I find very funny, because there's a Nickelback song where he says, "Look at this graph," and my coworkers can probably attest. I spend a lot of time creating Plotly graphics, and I think that it's a great way to communicate information outside of just the standard Excel documents and Excel graphics, as it provides a lot of customization that could be more tailored to your organization, such as custom fonts and colors. Thank you for watching. And at this point, we can open it up for questions.
Hey, thanks so much, Colin. That was awesome. I really like, it's often when you hear the word visualization, you have like these wild, like swiveling things that look amazing, but actually extracting any information from them is often very difficult. They look more amazing than they're actually practically useful. I thought they were. I thought some of your examples were both accessible and very clear in their intent. Just going to check it out, see if there's any kind of questions. Check YouTube. I'm just interested why you chose Plotly. This is not like a graphic package war. I know it's like probably the most popular package. Like in Mystic Pi, we settled earlier on before the war. Outcome of the battle between plotting packages had been got very far, we used Boca, which is a similar kind of like JavaScript front end in a lot of our visualizations.
Yeah, so when I first kind of started this project around a year ago, I started looking at a variety of different libraries, Matplot, Seabor, and Boco, as you mentioned. And ultimately, the reason why I decided to go with Plotly is because for me, it was the easiest to define a custom font, which was one of the features that I was explicitly looking for in my graphing, being able to employ a custom font. And I had some difficulties. I'm not saying that it's impossible to do that in those other libraries, but I found it to be really easy to do in Plotly.
Okay, I'm just going to bring, I think we've got some other people lurking in the wings. Wonder if I can add them. Just to show that there's more than just Deanna and Thomas, who's currently microphone camera muted.
Yeah, guys.
Yeah. Yeah, I'm curious, why did you want to create a custom font? Was that that seems like a bit of a challenging thing to want to do.
Mostly just to be in line with some of my company's branding, just for disseminating information internally and leveraging some of our enterprise kind of theming with Sophos fonts and Sophos colors. So I really enjoyed being able to kind of tailor and customize that as opposed to like having it be the default. I like it to be different enough that you can't immediately tell that I created it in Plotly.
Yeah,
that's super cool.
It looks like there's a question in the StreamYard chat asking, have I found Plotly to be fast enough for your needs? And does it scale well? I think so. I mean, I haven't necessarily tested it with like very big data sets other than like a few, hundreds of lines of data or thousands in some cases. But like in terms of millions of records, I haven't tested that out. But so far, I found it to be pretty useful. One other project that I started with last year after watching last year's presentation was looking at the Conti data set, which is a lot of messages. And I visualized every single timestamp in the Conti data set into Plotly, and that ran fine without any performance issues. But I also leverage Jupyter Lab to run it, which helps reduce some of the computational requirements on the actual endpoint or laptop that I'm leveraging.
Nice. Yeah, it was very good presentation, Colin. Thank you very much for that. And I have a question as well. So, are you currently using this kind of analytics for threat reports internally, or even for customers, or is it only for threat hunters and people in your team?
Yeah, we definitely leverage this information to help us understand the threat landscape. I mean, as someone who works at an antivirus company, we certainly can create trends and graphics on what we're seeing within our direct customer bases. But as it pertains to the global threat landscape, Ransom Watch is an amazing project. The gentleman, Josh, who runs it, he spends a lot of time updating his tools. And I think that out of all the solutions out there, if you want to understand what's actually happening in the ransom world, Ransom Watch is the best open source project to directly start to get that kind of information.
Right, that's cool. And
well, I had a quick question just about the use of notebooks within your company, within Sophos. Are you kind of a maverick, or is it fairly widespread? I'm kind of just interested, like across the industry, to get sort of anecdotal information about this.
So I'm a part of our threat intelligence team within our managed detection response service, and one of our kind of other teams that we work very, very closely with is our threat hunting team. And ultimately, there was some buy-in from both the intelligence analysts as well as the threat hunting analysts to spend some time learning more about Jupyter Notebook, provisioning servers, and some of my coworkers on the threat hunting side of things leverage Jupyter quite a bit for analyzing data and trying to identify potential intrusions. So there's definitely a lot of growing popularity with Jupyter Notebook, but it's a little bit newer for me and my coworkers, and it's definitely something that we're continuing to learn and spend resources learning. And thankfully, this conference in itself was something that really inspired me and motivated me to start learning, because I'd heard about all the good things about Jupyter Notebook, but it wasn't until last year when I watched where I was like, all right, let me actually sit down and spend the time to start learning. And I've really enjoyed it so far.
Yeah,
cool.
That's awesome. Thank you so much for sharing, Colin, and sharing like the tools and the packages that you've learned over the past year to better visualize and understand data. It's been really insightful to hear all the things that you've tinkered with and what you've learned the past year. So thank you so much for your time and an excellent presentation. It was really insightful.
Thanks for hosting me.
Yeah. Up next, we have Ryan Fetterman. He joined the Surge team after spending about a decade in the government sector and in consulting. He'll be discussing the topic of leveraging humans' innate understanding of 3 dimensions to revisualize, process, and analyze threat hunting data in a more Euclidean 3-dimensional understanding with Jupyter and various extensions. Looking at his abstract, I'm super interested and excited to hear what he has to say about this. So why don't you take it away for us, Ryan?
Cool. Am I coming up now?
Yes.
Awesome. Okay, so good evening, everyone. I'm excited to be here. My name is Ryan Fetterman. I'm a member of the Surge security research team at Splunk. And today I'll be talking about threat hunting in 3 dimensions. In this talk, we're going to walk through a real life security example that will help you understand some concepts about visualizing your data in 3 dimensions, which I found to be very useful for a variety of problems because it's something we kind of innately understand. It lets us see the shape of our data, look at the interaction between our variables, and do some cool things with math. The other thing I want to emphasize is kind of the strength of using something like Jupyter and a Jupyter Lab environment as a tool in parallel with our SIM products, where we have all of this great enterprise data. So I'll try to call out some of that as we go through this. So first, I embedded some links in here for after the fact, some resources. If you're interested in this type of work, please check out more from my team. We do a lot with this kind of data visualizations of security problems. The process we'll be following today comes from the Peak Threat Hunting Framework, which is something that my group put out last year. This is a comprehensive framework that contains more than just the threat hunting processes themselves. It talks about things from maturity to metrics, inputs and outputs for hunting. But at its core, it has 3 fundamental hunt processes. And the one we're going to be following today is called model-assisted threat hunting. This attempts to define a method where we're using a model or an algorithm to make a tough security problem more approachable, or sometimes as a creative means for finding the things we're interested in, the leads we want to locate for threat hunting. And lastly, if you're wondering the best way to do Jupyter data science alongside of your Splunk environment, definitely check out the data science deep learning app from Splunk. This is officially supported. It's free, even if you're not a customer. And it essentially lets you run a Jupyter lab in a Docker container or a Kubernetes environment in parallel with your Splunk instance. You can push and pull data back and forth. You can train and host models in different ways. It's really flexible, and it really gives you the best of both worlds there. So at a high level, the workflow we're going to be going through today, we're going to start with just some text-based data in something like our Splunk environment. Where we can enrich that, we can filter it down, we can push it over into our Jupyter lab, where we're going to apply some more enrichment. We're going to develop some quantitative metrics for the things we care about. We're going to put that into an unsupervised learning algorithm in the form of k-means. K-means will produce labels for all of our data points, and we'll use those labels to assign color values in a 3D scatter plot. Ultimately, we're going to end up with a view like this, where we have our data in an interactive format in 3 dimensions. And for the specific problem, we're going to be looking at using Euclidean distance to measure the distance between specific data points in our data set. And as I mentioned, this isn't a methodology that's specific to this problem. There's a lot of parts and pieces here that I think are good for you to take away and try and apply in your own security problems, or even not security problems, honestly. But we're going to walk through a security example that's going to help ground these concepts and make more sense out of this. So our case study is from a real world example. This was a joint research project that the Surge team did with Google around evaluating the security and risk of browser extensions in the Chrome Web Store. And an extension is just something you add on to the Chrome browser, which provides some
additional functionality, typically through like a right-click action or a little widget on your toolbar. And these in code are just like compressed archives with a little CRX extension. So we wanted to look at how you go about evaluating the risk of these. And it turned out to be a really tough problem because of a couple factors. First of all, there's just such diverse functionality of these extensions. They typically provide functionality like password management, ad blocking, language translation, coupon tracking. And within each of these compressed archives, there can be dozens of folders and files in different formats, JavaScript, HTML. They can be reaching out to web APIs, all depending on the functionality that they're providing. So from the perspective of diversity of functionality and diversity of composition, it's really hard to come up with a one-size-fits-all risk perspective for evaluating these. And we found that there's really no substitution for that human level, kind of manual level reverse engineering to evaluate an extension in the context that it's purported to be operating. And that's always kind of a disappointing conclusion because human analysis doesn't scale well. We need to find a way to make this problem more approachable. And that's where the model-assisted threat hunting method really shines at trying to take something that looks like complex and see if we can filter it down to a way that makes it more approachable. So we started by scraping all of the data in the web store. This is a data set which we have on the same GitHub as the notebook, so you can repeat all this analysis. And we're working with just some really simple features here. So we have the CRX value. This is just being used as a unique identifier for each extension in the data set. We have the name of the extension. We have the description from the web store provided by the author of the extension. And we have pulled the extension icons for this analysis. And what we decided we could tackle here was the idea of masquerading. So masquerading is a challenge in any app store, and it basically happens when a bad actor develops a malicious browser extension in this case. And in order to get users to install it, they try to disguise it, make it like imitate a legitimate kind of established extension and ride on the credibility of something that's already popular. So in this case, we can make the assumption that a masquerade of a popular extension is going to attempt to look similar, maybe with the icon. It would attempt to sound like the another icon or another extension in the form of the name. It might share similar characteristics in how it's described. So if we look at our data, we have different fields that we can use for this kind of comparison. So there's a couple metrics we came up with on how we can enrich these baseline fields to assess similarity, and we'll go through these as we apply them. But ultimately, we have to start with a target for comparison. So similarity really only works when it's relative to another extension in the store. And we figured that the most popular extensions in the store were likely to have a number of imitators and possibly some malicious extensions masquerading as these. So here's the CRX values provided just as reference that you can pull any of these, replace this value, and repeat the notebook workflow to see the results for other extensions in the store. But for this example, we're using the CRX, which gives us the Google Translate as our target. So what this means is we're saying the Google Translate icon, Google Translate name, and the description of the browser extension are our baseline. We want to look at all 140,000 other extensions in the store and assess their similarity to our target, the Google Translate extension. So we have some functions for applying these enrichments to our data based on the ideas that I just described. And what I think is important to realize here is that for each one of these metrics, the notebook has to make 140,000 and a half calculations to apply each of these metrics. And then because we're doing a pairwise comparison between what we've set as our baseline and every other extension in the store, we're making 140,000 comparisons along each of these metrics every time we run this workflow. And this is a case that really validates the importance of using something like a Jupyter Lab environment aside from our sim, because in this case, we may want to refine our hypothesis. We may want to try different extensions in this workflow. We may want to tweak things along the way. And ultimately, the measurements that we're making kind of have ephemeral value. It's not something that we want to write into long-term storage. So we don't want to use the storage or the resources from our sim platform. So it's really helpful to have this Jupyter Lab on the side where we can rapidly prototype through some of these ideas. Okay, so to make sense out of some of the metrics we're using, the first thing we're looking at is naming similarity. So this is going to be applied on the name field for our target. So we're starting with the name, Google Translate. Levenshtein similarity is essentially doing character replacement substitution on this name and saying which are the next closest extensions to this name when I start to modify the characters. We can represent this quantitatively because it's a similarity measure. We use min-max scaling here for all of these so that we have equal axes when we go to plot in 3D. But the important thing is we're getting similarity measures of things that look similar in name to Google Translate to start with. The next thing we looked at was icon similarity. And what we applied here is called color moment hash. This actually creates a hash value of every icon in the store. And what it's looking at is the color profile and the structural composition of the icon. It takes that information and compresses it into a hash. And when we do that across every icon in the store, we can then compare hash values using the concept of Hamming distance, or when we kind of invert that, Hamming similarity. So we look at the Google Translate icon as our baseline. We look at the Hamming similarity between that hash and every other icon hash in the store. And then we produce a metric, which we add to our data frame. And we see we get a 1.0. 1.0 is a perfect match. So Google Translate's always going to match with itself, but we find some others that are also actually a 1.0 match, which is interesting. So we can run some extra code to pull those, and we can see that we do find identical clones using this method to identify where the icon is just a copy of the Google Translate icon. And as we move down this similarity scale, we can see that we're getting good results. We're seeing the same kind of color profile here, the same kind of structure with just slight modifications to the icon, clearly trying to at least imitate the Google Translate icon, if not completely masquerade as it. So lastly, we're looking at the description field, and we used cosine similarity, which is going to look at this string, convert it to a vector, a numerical representation, do the same thing for every other description in the web store, and then compare the distance between the numerical vectors to give us a similarity value. So again, we have this scaled, and we're looking at the next closest to the description of the one that we care about. So now we have 3 quantitative dimensions for the similarity metrics that we decided we care about for this problem, which was similarity in the appearance of the icon, similarity in the name of the extension, and similarity in the description of the extension. The last thing we're going to do is put the quantitative dimensions into an unsupervised learning algorithm in the form of k-means. So k-means tries to minimize the distance between points in a cluster while maximizing the distance between the clusters. It tries to get clean separation of the data in your data set. And it makes sense for this application because we're comparing similarity across 3 dimensions that may not have any relationship between the variables since they're all totally independent. And what we produced here is a Plotly visualization. So this is totally interactive. The green dot up in the right corner is our target extension, and the rest of the dots are all individual extensions plotted in these 3 dimensions. So we can explore this. We can look at the data that we have here, zoom in and out. You can mouse over these in the notebook to see the details of individual data points, but it kind of breaks in presentation view. But this gives us a view to understand the data that we have here. The last question is really coming up with some kind of composite metric to look at similarity across the 3 dimensions that we care about. And the way that we came up with doing that was using some geometry, actually, in the form of Euclidean distance, which actually will calculate the distance between our target data point and each of these specific data points, which represent a close peer in the web store. So this is something else we can easily implement in Python. We get a quantitative measure, which we can add as a column in our data frame and then sort it in ascending format so we can find the next closest peers. And ultimately what we've done is we've gone from looking at 140,000 extensions, coming up with a hypothesis and kind of refining that until we had the idea of looking for masquerading extensions in relation to a specific target that we can set to whatever we want. And we come out with a list that's much more approachable for doing what we determined was the required level of human kind of reverse engineering analysis to really evaluate these. So just to recap, this is the workflow that we went through. We started with just some text-based data, which is what we have a lot in security, but there are some creative ways to make text data vectorize or come up with some kind of quantitative way of representing it so that we can get our data into 3 dimensions, look at some of these features and understand the relationship between variables. And lastly, we used Euclidean distance to look at the difference or the distance between the specific points we were interested in. But there's actually a lot you can do once you have your data into this kind of format. So it's just a good process for exploring. So as I mentioned, the resources for all of this are already out there. The data as well as the notebook are on Splunk's GitHub. This presentation I embedded as a single HTML file on my GitHub, and I'm happy to talk to anyone on Twitter that wants to try and work through this. So that's it for me, and I'm happy to take questions, but thanks for your time.
Yeah, thank you so much, Ryan, for such an insightful presentation. I feel like it's so interesting to take kind of a psychological human understanding of space and leverage that with data to quantify things like similarity in different capacities and with different methods. I feel like that's such a unique thing to do. It's something that I've never heard about until this presentation. So thank you for talking to us about that. There was a lot of messages in the chat about the kind of application of quantifying similarity in that 3D vector space. I feel like that's something that people have a lot of interest in. Where unfortunately we're running close on time and I don't think we have time to ask questions, but if you want to look at the chat, there's a lot of discussion about this right now. So yeah, thank you so much for your time, Ryan. Up next, we have Ismael Valenzuela. He is the Vice President of Threat Research and Intelligence at BlackBerry Silence. He is the author of several cybersecurity training courses and is the founder of one of the first IT security consultant companies in Spain. He'll be talking to us today about how defenders can tackle unknown aspects of proprietary protocols that are widely used by threat actors and detect and flag unusual behavior in traffic using Jupyter notebooks and Python libraries. So take it away. I'm really excited to hear about this topic.
Thank you so much, Diana. I'm very excited to be here, and I thank all the organization of the Jupyterthon for having me. My first time in here as a presenter. So let me see if I can share my screen, and that would be a good way of getting started, right? All right. So I think it's cue to backstage. There you go. Awesome. I love when technology works. Well, thank you so much. Yes, we're going to talk about hacking proprietary protocols. And I just have a few slides, but I'm just planning to show you the Jupyter Notebook because I think that's what everybody is here to see, right? That's the main reason why we're here. So we're going to talk about proprietary protocols and how we can dissect them. In this case, with pandas, right? So of course I had to use AI because we have to sprinkle everything with AI. So we could show the pandas here, looking at Jupyter notebooks and dissecting proprietary protocols. So why proprietary protocols? Well, there's a lot of different use cases here. The first thing is that sometimes we can find this in the context of malware analysis, right? It's not every day that we see it, but we have seen this over the years. We see this a lot in applications, for example, medical applications, in manufacturing, sometimes even in educational software. And what happens when you sniff that type of traffic and you open up in Wireshark, right? One of our favorite tools. If the Wireshark has an RFC for it, it will decode it, or if it has a parser for that protocol, it will decode it. But if it's a proprietary protocol, it would just show you hexadecimal. So what do we do with this? There's no RFC available for these proprietary protocols. And what's the risk? I like to talk about, think red out blue, like think as an attacker to become a better defender, right? So we're going to look at the red team angle. Why are attackers interested in this type of protocols? Well, if I'm able to dissect a proprietary protocol and I know that it's used in a medical field, in a particular manufacturing plant, maybe critical infrastructure, I could try to use that to blend my traffic, maybe my command and control within this proprietary protocol, because we know that most likely nobody's looking at it. If it's something like, for example, a supply chain attack, in many cases we see these proprietary protocols being used to reach out to update, right? For example, a device. And now if I'm the attacker, I could try to use this avenue maybe to provide an update to this device and start a supply chain attack in this particular way. How about a blue team for defenders? Well, obviously we cannot secure what we don't know, right? So this can lead to more vulnerabilities, and we have seen very recent examples of many appliances and devices where security by obscurity doesn't work, right? And having an understanding of this is just going to also help us to see if there's any, for example, confidential data, right? Sensitive information that might be traversing the network in an unencrypted fashion. It might be encoded, but maybe not necessarily encrypted. So lots of different possibilities here in applications or use cases. Now, from a red team perspective, this is a general kind of a methodology, right, to follow, and we're going to see how we can do this with Jupyter notebooks. An attacker would dissect the protocol, maybe fuzz the protocol, analyze if there's any crashes as a result of this fuzzing, and finally writing an exploit. Now, of course, all of these things will take a lot of time to consider here. It could take like a whole semester, maybe going through something like this, but we're going to focus on what we can do from a practical perspective. And more than a red team approach, I'm going to use a blue team approach here. But think about these two applications, right? If you work in a red team, for example, we're going to be using Jupyter notebooks. Of course, we could also use a more traditional approach, old school, which I still love, right? Something like Zeek, using maybe Kibana dashboards. Roberto has a lot of good resources on these as well. But we're going to use obviously Jupyter notebooks and pandas libraries that, I'm going to assume that everybody here is familiar with that. But if it's not, it's essentially like, think about a huge spreadsheet in memory, right? Where you have columns and rows, and we can put all the data in memory of our system where we're running the Jupyter notebook, and we're going to parse the data. We're going to normalize it. We're going to correlate, and we're going to do statistical analysis. And also some visualizations, right? Because that's going to be very useful to understand what we have here. Now, everything that I'm going to be discussing in this presentation, it's available in my GitHub. So about security, Jupyter notebooks, and that's where you're going to be able to see everything that I'm going to be discussing here. how do we do this first thing, right? We talked about this high-level process, dissecting a protocol. And this is kind of, there's no official way, right, of one size fits all for this. There's no magic for dissecting protocols, but this is kind of a general approach. The first one is to try to simplify the scope, right? I usually say, divide and conquer. When you have a big problem in front of you, try to reduce the size of the problem and try to find maybe some characteristics, maybe some patterns that we can enumerate. Embedded networking, we're going to be looking at what's inside of these payloads. We're going to see if we can find patterns within the payload, and we're going to look for clear text clues. In many cases, we see proprietary protocols that, again, are used maybe in critical applications, aviation, right? They can contain these clear text clues. There's a lot more that can be done. Just for the sake of completeness, I wanted to add all these other bullet points here, or points, but we're not going to be considering all of them here. So I'm looking at the comments here. I feel we need a Jupyterthon drinking game. Well, I have my water here. I don't know if this counts. So simplify scope. That's the very first thing we need to do. It's impractical to look at every single byte or every single packet that we have even in a packet capture. So we will need to start our process somewhere, right? We need to start looking at what this protocol looks like. It really helps a lot when you have a bunch of different captures. If you only have one packet capture, it's going to be statistically, less representative. So it's going to be harder to find out those patterns. But if we have multi-captures of the same data, the same type of protocol, maybe across one device or multiple devices, that's going to be very useful. So what we have done for this particular presentation is to create a fake protocol, because I didn't want to use something like, that is proprietary from a particular organization or a particular vendor. For example, medical devices like, or medical protocols like RWAT, created by General Electric. We don't want to go through something like this, so we just created a number of PCAPs with a fake protocol generator, and you're going to find all of these links to all of these scripts in our GitHub. But we're going to be looking at three things. We're going to look at the length of the packets, we're going to look at the type of the packets, and we're going to look at frequency. So imagine that we have this proprietary protocol. We have one PCAP here, but there's several of them that we're going to be showing in the slides and in the Jupyter notebook. And we open this up in Wireshark, right? What do we see here? Well, for somebody that has been doing traffic analysis for quite some time, as I usually say, you can probably see the matrix, right? You can probably look at, okay, so I know that most of the communications are, between these two IPs. We know that 140 sent a SYN packet to 135, so 140 is starting the conversation. We can look at the distribution between TCP and UDP packets. Very quickly, you can identify that there's a number of TCP packets, and then after this number of TCP packets, there's a UDP packet. And that's kind of a pattern, right? Will this repeat across other PCAPs? You're going to see that that is the case. These are, some general quick observations. TCP, UDP traffic, ports, the length of these packets. But is there a better way of doing this? Sure, of course, Jupyter Notebooks, right? So let's have a look at that. This is the protocol distribution, and I'm going to show you the code that generates this. We're not going to go through everything line by line, obviously, but just to give you an idea, we have a function that takes a PCAP file, and it will put this data into a pandas data frame. This is going to be very useful for the visualizations that we're going to use later. So we have here is the PCAPs. Again, you're going to find all these files in my GitHub account. And then we are ingesting or sending all of these PCAPs to this function, and they will return a pandas data frame. So we have all of these four data frames, one per PCAP. So the next thing we do is we're going to be just doing these basic visualizations to look at the protocol distribution, right? We know that protocol 17 is UDP, right? Protocol 6 is TCP. So the majority of these packets for this particular PCAP, right? This is just PCAP number 1. We can see that the majority of them are TCP. If we look at the addresses and in the payloads, we can see that the majority of the packets are being sent by 140, and 135 seems to be the one receiving the traffic, right? And we can do essentially the opposite statistic. We can see how 135 is receiving most of the payload. This is just very, very, very basic stuff like destination ports. Most of this traffic is being sent to these different ports, right, based on the bytes received. Now, do we really need to do a Jupyter notebook to get all of this? What do you guys think? Just looking at the Discord here. Well, we talked about Wireshark before, right? So we can essentially use Wireshark for all of this. And yes, you can go to Wireshark statistics, right? Conversations. You can get a summary of all of these. You can see pretty much absolutely everything that we're showing here. However, all of those are pre-canned visualizations. With Jupyter Notebooks, we're going to be able to go further and build visualizations that we cannot really easily see in Wireshark. So again, going to Wireshark, for example, we can now say, show me all the TCP packets that have the push flag on. So we know that these packets are going to probably carry some sort of payload, right? So that's the filter that we have here, TCP and TCP flags 0x018, which is essentially the flag that we need for, or the filter that we need for the push flag. And we can look at the length. Again, is there a more simple way to visualize this? Absolutely. We're going to show that in a second. Same thing with the UDP packets, right? So we do this for TCP and UDP. Something interesting that stands up is that in these packets, the UDP length is always the same, whereas in the TCP, it varies, right? How can we see this? Well, very easily, we can just go to our Jupyter notebook and say, describe or show me the distribution for each of these different protocols, protocol 6, TCP, and protocol 17. And we can do this for each of these different packets, right? So for UDP, protocol 17, we can see that it's always 64, essentially. But for protocol TCP, it varies. Again, we can create another visualization, and now we start to see something interesting, right? Don't you think that there's some sort of a pattern here? We can see the TCP packets and then the UDP packets, right? We're just plotting the length based on each of the packets that go within this packet capture. But there seems to be some sort of a pattern there. If we try to analyze this from a Wireshark perspective, in a way that it's very similar to how we do reverse engineering in other fields, right? Like in malware, for example. If we're reverse engineering this protocol, we said before, it's not practical to look at every single packet, right? It will take us forever, but it's useful to look at one packet, concentrate on that, and then see if we can find other patterns, some characteristics that repeat across other packets, so we can try to create some groups. And then we're going to see how we can do this with Jupyter notebooks, right? So for example, if we look at the payload of each of these packets, we can see that there's a group of 4 bytes that they seem to repeat, right? We can see the first group here, this group there. You can also see this one. They seem to repeat, right? How many bytes do we have? We have 1, 2, 3, 4. Interesting. And then we have this field 0002, 0001. We're just comparing, right? These different packets to see if there's something in common. There is some similarities there. So this is what we're going to do now. Since we know that there's some patterns, some similarity within this payload, we're going to try to use Jupyter notebooks to find out how many of this group of bytes repeat across the payload. So what I did was to take a group of 1 byte, 2 bytes, 3 bytes, 4 bytes, and then see how many times this group of n number of bytes would repeat across this payload. So this is what we can see here. I'm going to show you this on the notebook, just to get out of the slides for a second. This is what I showed you before, the payload length. And this is the function, splitting the payload column into sets of 4 characters. So I did this with 1, 2, 3, 4, and just explore the data, right? This is just data exploration at this point, trial and error. And then I found out that when you group by 4 bytes, so this is what this lambda function is doing, just getting the payload and then the raw payload, and then grouping this in n number of bytes. When I look at groups of 4 bytes and I plot this, I realize that there is one group of 4 bytes that repeat a lot. What could this be? Anybody? Looking at the chats. No one? Any hypotheses? Since we're talking a lot about hypotheses here. Well, if you have looked at proprietary protocols before, you probably have the suspicion that this is an IP address, right? This is very common. This IP address could be used for some sort of control mechanism, again, to update the device, asking this device to connect, maybe somewhere else. And this is what this group of 4 bytes are, right? This is essentially an IP address. And what you see next, if we go back to the slides, is that we're going to see this number of bytes, this IP address, these 4 bytes repeating a lot across this payload. So the next thing that we do is we do some data exploration. I'm looking for where in the payload, within the packet, these 4 bytes occur. And if we look at the code, right, and the results of this code, we can see that this particular group of bytes that translates this address happens to be in position number 0, byte 0 of this payload, and it happens 24 times. So we repeat a lot of times. Also, this other one, 135, but there's a bunch of other IP addresses embedded in these packets. So we would have to investigate what's the role of each of these IPs. But again, even without knowing much about Wireshark or knowing anything about these layers or this protocol, remember there's no documentation about proprietary protocols in many cases. We're able to decipher, to decode what's in here by just doing some data exploration with these notebooks. Now let's get into something more fun. I have 4 different PCAPs, 4 different captures for this proprietary protocol, and I'm gonna just going to create a time series. I'm going to plot the PCAPs, whether it's TCP, UDP, over a time series. So from packet number 0 to the last packet in this capture, and I'm gonna do that for these 4 PCAPs. Let's have a look at the notebook again. And we're going to see, there you go. So PCAP number 1. What do you see here? Seems to be a pattern, right? What do you think these UDP packets are? They occur every certain number of TCP packets. So we have seen this, especially in the context of command and control. We call this a heartbeat. These type of heartbeats are also very common in medical applications, manufacturing plants. And the next question is, what's inside of this heartbeat, right? So that's what we're going to be answering now. Can we do that with Jupyter Notebooks? Can we look at the contents of these payloads of these UDP packets? So very simple, right? We just do a hexadecimal an ASCII dump or a print. And I don't know if anybody recognizes this. What do you think this is? I'm going to give you a second there. This looks like maybe geocoordinates. Well, I mean, you can just like Google this, right? Or ask ChatGPT. But yes, if you Google this, you're going to see that these are effectively geocoordinates that are embedded within each of these UDP packets. All right. So since we know that these are geocoordinates, what can we do next? Well, we're going to go and extract those geocoordinates out of these PCAPs, and we're just going to map them, right? So in this case, I'm using this library called Volume. Let me just go and show you that in the notebook itself. And I'm just going to do that for a couple of PCAPs, extract all the coordinates from the UDP payload since we know what it is now. And we're going to, well, just plot it. And we can see that we have a couple of geolocations here. Very common in different type of protocols that we see in manufacturing, the medical field, sometimes aviation, and a lot of other critical environments too. So that's essentially one of the applications that we can do. Not super complicated. This is very useful for not just these applications that I mentioned before, like medical devices, but also IoT, ICS networks, malware analysis. And if you want to take this to the next level, something you could be looking at is, for example, looking at similarity between these payloads. Maybe looking at the Euclidean distance, as Ryan mentioned in the previous presentation. Just some ideas for you to think about this. This is about exploring the data. We often talk about ingesting JSON files, looking at maybe ingesting data from sticks or a taxi server for threat intelligence purposes. But I haven't seen that many presentations on analyzing traffic with PCAPs. So I thought this would be interesting. Obviously, always building on top of what others have researched. And if you find this useful, please let me know. I don't know if we have time for questions, but this is also part of one of the classes that I teach, and I'm a co-author of with Douglas McKee. And if you look at our GitHub repo, you're going to see a lot more information in there. So how am I doing with time? Do we have some time for questions? I cannot hear you. I don't know if it's... No, I think you're on mute.
My bad. Yeah, that we have a good amount of time for questions. Thank you so much for that talk. That was super insightful. I feel like navigating the mystery of proprietary information is so important, especially since a lot of our jobs and a lot of our field will involve behavior with threat actor kind of behavior with these protocols, this proprietary information. So kind of reverse engineering, kind of backtracking and dissecting the PCAPs and dissecting this data is super cool. And it's something that I also haven't really witnessed a lot. We have a question in the chat. If anyone has more, feel free to drop them because we have a good amount of time for questions. I have my own questions. I'll read off Pete Bryan's first question. He asked, in your experience, how big of a PCAP file is reasonable to work with in one go in a notebook without hitting any major performance issues? He realizes that this is a very compute-specific question, but wants to understand if this is something reasonable to run locally on his laptop, or if he has chunkier PCAPs, does he need to think more about a dedicated compute for this?
Yeah, so this is a very good question. Remember that what we're doing here is data exploration, right? So I'm not looking at building a system to continuously monitor or to continuously process all of this traffic. So with that in mind, I would recommend sampling, right? So if you're doing this type of reverse engineering, just do some packet captures. You're going to be limited by how much memory you have, right? Like with everything else, with pandas. So if you're analyzing PCAPs that are a few hundred megabytes, that should be pretty reasonable. I wouldn't just, get big gigabyte PCAPs and do this analysis. Start with something small, and as you do your findings, document your findings. So one of the things that we teach in this class is to document these proprietary protocols using Scapy, creating layers to match that, and then validate this with larger with larger PCAPs. And at that point, I wouldn't just bring everything into a pandas data frame. What I would do is create my own, Python script, something with a Scapy, for example, and then running this Python script against those larger PCAPs to validate my findings. And then if something doesn't match, then go back to your analysis, getting just maybe one PCAP or half a PCAP, right? Focus on some of the samples and try to do your analysis based on that.
Okay, that makes sense. Yeah, thank you. Someone else, Christian, has a question in the chat as well. Have you tried network flows slash proxies or logs with the same approximation?
You know what? Not in this particular way, but with network flows, assuming that you have, data to enrich, for example, you can do a lot of cool things. And I think, some of the, I think we're still early in the conference, but I'm pretty sure we're going to see some talks touching on that. But yeah, absolutely, I'm a big fan of NetFlow data. And if you have, for example, information about, let's say, a NetFlow capture, you can start building like a map of who's connecting to who's talking to who. That can give you a good idea, right, of what's happening on this network, both for red team and blue team purposes. If you have information about identity, right, identity logs, now you can start like enriching that and looking at, what is user Bob doing, right? What is he connecting to? Absolutely, I like your thinking, guys.
Yeah, the chat is bursting with questions right now. I feel like people really are interested by your talk. Cyber War Dog is asking, when you deal with network traffic that contains malicious payloads, how do you handle that from a Jupyter notebook perspective? Do you use other notebooks to handle other reverse engineering steps? Do you analyze network traffic and malicious payloads on the same notebook server?
Oh, wow. Roberto, that's like 3 questions in one. Come on. Do you have other, you know what? I have to admit this. I'm not very well organized. I'm more like a quick and dirty. So it's like, I got to do something. Let me just bring everything into this notebook. And I keep copying and pasting things from other notebooks that I have and just like creating another one. And I'm not super well organized with this. So I'm hoping I can learn something from this conference on that. And I'm pretty sure you can teach me quite a few things on this topic too.
Yep. Yeah, I feel like I have so much to learn from Roberto. I'm sure you can,
For Databricks, yes. So I'm a big fan of Databricks. I see that on the comments too. And you can do Jupyter notebooks on Databricks. So if anybody's looking at, or has this type of solution, data lake, and you're looking at doing hunting on mass, right, on scale, that's one way of doing it.
I think
you can ask.
Oh yeah, go for it.
Ask Ryan Cobb from the first talk about organizing notebooks into kind of production pipelines. Super cool stuff.
But I'm a researcher, right? I work in a research team, so but absolutely. Nice mysterious talk. Okay, so I hope it wasn't like too mysterious, but
Diana, do you want to do? Ashwin had an interesting question.
Yeah, I think Ashwin had a question. He asked, are there any libraries to make it easier to load into data frames? I saw you have custom codes written to read, parse, and load. Have you encountered issues loading PCAPs?
No, I haven't seen any libraries, right, for that, other than that code. And I built that, based on other code that I found, but I haven't seen a library for this. The best library to manipulate PCAPs in Python is definitely Scapy, but I haven't seen any other specific library to bring this data into a pandas data frame. But this function that I showed you that you can see in the Jupyter notebook leverages Scapy for this purpose.
Could be a great topic for a talk for the next Jupyterthon. If somebody wants to create one, show us how it works.
Right.
Yeah, I think that's all the questions we have in the chat. We have a break in about 5 minutes. We can jump into that. I don't know, Ian, if you had any questions for yourself.
No, not really. The only thing I kind of made a comment that I think is a question about scaling. I mean, there are things that like Dask that allow you to use pandas at scale, even on a single machine. It can like use multiple CPUs and virtualize. So you can deal with, if you need to deal with like gigabytes of data, there are ways of doing it. Not with pandas, because that like loads everything into memory, but
Yeah.
It's a kind of a pandas like, it's got pandas sort of API. So
And again, the purpose of this is to do the reverse engineering, right? It's to find out like those patterns. Once you have found those patterns, now you can just write if you want to write like a Lua parser, right, and bring this. You can create your own parser for Wireshark, for example, and at that point, I feel there's other tools that will be more effective at analyzing now this traffic at scale.
love the T-shirt, by the way. It's very cool.
Yeah, thanks.
Okay, we'll just go for a 5-minute break, I think, and then we'll see you at
I think in about
Yeah,
8 minutes at
about
2:10, depending on
your
where you
time, yeah.
are.
6:10 Eastern time. Okay, bye for now. Thanks, Ishmael. That was fantastic.
Hello, and welcome back to the Infosec Jupyterthon 2024. Up next is another accomplished speaker, Pete Bryant, joining us from the AI Red team at Microsoft. I had the privilege to work with them when I first joined as a security researcher. And let me tell you, there's no doubt about Pete's expertise in his work, and you can see the impact his 8+ years of career had. He's here to talk more about how he utilizes Jupyter notebooks in his daily life as an AI Red teamer. So get pumped for this talk. The stage is yours, Pete.
Great, thanks, Isha. Let me just present and then get this going. Cool. Hopefully that should appear for everyone. Great. So as Isha mentioned, I am going to be talking a little bit about using Jupyter notebooks for AI red teaming. So some of you who have been at the Jupyterthon before will know me as someone who works on Mystic Pi and blue teaming side of things. Well, I've recently had a bit of a career change and I'm now part of the AI red team at Microsoft. So AI red teaming is a bit of a newer topic. So I thought I would start by giving a little bit of an overview about kind of what do we mean by that. So going back from red teaming to AI security and kind of what does that mean? The answer is it means a lot of different things to a lot of different people. What it means to us here at Microsoft is both the security of AI systems from what you would think of as more like traditional cybersecurity perspective, like do they introduce any confidentiality, integrity, availability harms, but also the safety and responsibility that comes with AI systems. Are they fair? Are they reliable? Are they transparent? Are they inclusive? And Microsoft has a whole set of AI principles that you can go online and read. Like the Responsible AI Standard that Microsoft publishes is a very detailed look at like how we think about AI systems within Microsoft. And so how does AI red teaming kind of fit into that picture? Well, AI red teaming is the process of testing AI systems to ensure they don't cause intentional or unintentional harm to the users or the organizations that are using them. And so what my team at Microsoft does is test Microsoft's AI systems that we're releasing, everything from kind of like the raw model level up through to kind of fully polished and integrated features in things like Office or Azure. And what we do is test them to ensure they kind of like meet the principles of responsible AI and secure AI that we've set out as Microsoft. Now, it's a little bit different from maybe what you would think of as traditional red teaming. It's a lot more open and white box than you traditionally see. Really, from that perspective, it's a lot closer to pen testing than red teaming. We also have to think about it a little bit differently. We're not just simulating an adversary trying to attack a system. We're also simulating regular benign users because we also want to make sure that an AI system someone's using isn't causing harm to them or returning harmful content to them in the normal course of activity. And this is really kind of a new thing that is part of generative AI testing and is very different from a security tool. You know, if you're using, I don't know, say Word, if you're using Word, you don't expect Word to kind of like suddenly produce harmful content for a user unless they typed it in. But once we add an LLM into that, that's a whole different ballgame, and it could produce that content. So we really need to kind of think about it. It's also a space that, as you can imagine, is rapidly evolving. Again, even today, we've seen some pretty major leaps in what AI technology can do with OpenAI's new text-to-video capabilities. And really, that's kind of been the theme of AI over the last kind of couple of years now. It's rapidly evolving. And AI red teaming has been in the same space, rapidly evolving with the technology and maturing as a discipline. We're still some way behind traditional red teaming in terms of maturing. Like we don't have all of the tooling and process and language that exists around traditional red teaming. You know, there is no Metasploit or Kali distro equivalent for AI red teaming currently. It's not to say it's not going to be coming soon, but we are still building that foundational stuff that does exist in security currently. And really, for me, this has been one of the fun elements of moving from a traditional cybersecurity role to an AI security role. We're going back in time almost and trying to solve these foundational issues again. So as red teamers on an AI system, what are we looking for? Well, a number of different things. Some of the things that you might be familiar with are jailbreaks, and we categorize them into two types, direct and indirect. So a jailbreak is effectively where you're trying to break out of the instructions that an AI system has been given to get it to do something different, unintended, and potentially harmful. Direct prompt injection would be where a user is actively putting something in directly. So we think of ChatGPT, open up ChatGPT, type in. If you think of jailbreaks, that's probably where you first go to. Indirect prompt injection or cross-site prompt injection, XPIA we call it, is where you attempt to get an jailbreak injection into a system by indirect means. So if you think about the capabilities that are coming to a number of features, they have the ability to do things like summarize documents or email chains. Well, as an attacker, if you can put an instruction for an LLM somewhere in that document that's been summarized, it could potentially be processed as an instruction. So rather than summarizing it for you, the LLM interprets it as a new instruction and goes and does that thing instead of what you've asked it to. We also look for a whole bunch of things around, as I said, like bias. It's a big concern, but violent content, ungrounded content, or sometimes commonly referred to as hallucinations, and also areas of specialist concern. If you've got an LLM giving you financial advice, we've got to think about that protected domain and that context as well, and the specific harms that happen there. So that's AI red teaming in 5 minutes, probably the quickest intro possible. Now, where do notebooks come in? AI red teaming has a really broad scope. You're not just worried about security threats, you've got to worry about bias, you've got to worry about responsible AI, you've got to worry about language and cultural elements. So we've got to scale really broadly. Also, you're testing a system that is non-deterministic. This can be really frustrating. If you think about a web app, you're testing a web application, you send something to an API, the response is going to be pretty reliable every time. An LLM, on the other hand, is pretty different. You can give it the same prompt 10 different times, and it might give you 10 different answers. So not only have we got the breadth of options to test, we've got to test it repeatedly to understand where the consistency is. And finally, again, a little bit different from traditional cybersecurity is when you're testing these things, you are exposed to harm to yourself. If you're trying to see if a LLM can produce harmful content, that means as a tester, you're looking at a bunch of harmful content. Now, notebooks provide a platform to scale out, to cover a breadth of cultural and linguistic context that is hard to do manually, and also helps you remove yourself from the harms that might come your way and protect the red teamers effectively. So I've got a notebook showing you a few examples of this. You will see I've already pre-run the notebook. The model I'm using had a bit of a latency in responses, and given I've only got 15 minutes, I didn't want to run it live and have us all sitting here, but I'll talk you through some of the examples. So benign prompt testing. I talked about the need to test a benign usage of the system to make sure it doesn't produce harm. And again, I mentioned that LLMs can be non-deterministic. So quite often we just want to test a whole breadth of things. So here's a really good example. What I'm doing in a notebook is using an LLM to help produce multiple variations on the same prompt that I can then just run against the system and see how they respond. So here I'm writing a song for my dad's retirement in the style of a Bollywood movie. I just want 10 versions of that. I don't want to have to think about it. LLM can do it. Notebook's a really nice, easy way of doing this. All I'm doing with this GPT helper function is calling a GPT-4 model that I'm hosting in Azure OpenAI. Another thing that is really useful for notebooks in this case is scraping stuff off the internet to use in the testing. we found that there are plenty of places on the internet that are hives of malicious LLM activity. Some of it is kind of very structured. There's a number of good websites that host jailbreaks that work and don't work. But also things like 4chan and Twitter are constantly trying to iterate on prompts to create harmful material. And notebooks are a really good way of leveraging some of that to help you. So we can scrape stuff, or in this case, to pull a bunch of known jailbreaks from GitHub, process it. I can then send that to whatever system I'm testing, and very easily and programmatically see if that's been triggered. So here I'm just kind of like pulling it down from GitHub, process all the prompts. I can then, depending on what system I'm talking to, take those prompts and throw it at them. I mentioned XPIA earlier. Now, XPIA can be quite a slow process to generate manually. Again, notebooks are great for this. So a common way of trying to trigger a XPIA issue is by putting a set of instructions within some delimiters within a document or some other product. You never quite know what those delimiters are going to be and what's kind of being used in the system. So again, use an LLM and a notebook to automate all of this. Give me a bunch of delimiter options. Thank you, GPT. Give me a bunch of default text to put around it. Again, I want to put this into like a legitimate seeming Office doc. So I don't want to have to write the Office doc. Thank you, LLM. And then I can use the features of Python to very easily create a whole bunch of documents for me and to vary it for me. So again, with these systems being non-deterministic, you want to try as many variations as possible. And some of the things you might want to try is like, do you want to put your prompt injection at the start of the document, at the middle of the document, at the end of the document? Will that have any kind of impact on it? Well, the great thing is using a notebook, I can just create a whole bunch of options for me. So here I'm just using some very simple Python functions to take the paragraph of text that the GPT helper has generated for me, take the delimiters that it's generated for me, and take these jailbreak prompts that I've stolen from the internet, and then generate a whole bunch of different Word docs for me with the different prompts and the different delimiters in different parts of the doc. Then I can go and just test all of them in one big go. Nice and easy. Also, as I mentioned, we want to test for kind of like harmful content that is not necessarily a security harm, but is maybe kind of like responsible AI. Like you don't want your AI system saying horrible things about people. So sometimes you need to test that on like high profile people. So in this example, I'm trying to test against politicians. Like, can I create can my LLM write a poem about a politician that is less than flattering? As someone who lives in the US and consumes English-speaking media, I know US politicians and British politicians pretty well. The rest of the world, not so much. So again, use my LLM to help me. Then I can see if my LLM can write a horrible poem about any of these people. You'll see I get all my kind of responses back. Now, do I really want to kind of have to read each one of these? And let's say what I was asking it to do was something a bit more kind of harmful than write a disparaging poem. I might not actually want to read all of that content, or again, if this is imagery, look at all that imagery. So again, by doing this all in the notebook and kind of building the process around it, I can ask another LLM to rate the response for me, see if the response I'm getting back is insulting or not, and save me from having to be exposed to that harmful content itself. So that's a very, very quick view of kind of some of the things you can use Notebook for to help you in red teaming. There's a lot more I could go into on this topic, as you can imagine, and there's many, many kind of further options for it. One that I wanted to kind of flag up for you is a kind of utility or an approach called pair, which is a pretty common and popular one, which again is not necessarily notebook specific, but I think if you were implementing this, a notebook would kind of make an obvious place. But rather than having to, as I've done, create prompts and send them kind of manually, you can develop a system using your own LLM that will do multi-turn queries with a target LLM and kind of perform a lot of these attacks for you and then flag back when something has gone wrong effectively. So taking all of the, or many of the steps that I kind of individually talked about there, putting them into an end-to-end package for you. This pair approach is a really good one, and is one that's available online. Like it's a model that you can go look at. It's a paper, and you can see from their results they've actually had pretty good success at jailbreaking some of these models using this approach. The other kind of like aspect that you can look at is again probably something you would want to use a notebook for. You don't have to, but make life easier. Is trying to fine-tune your own LLM or small language model to be offensive. So if you take GPT-4, say, and try and ask it to write malicious prompts for you, most of the time it's going to say no because it's been safety aligned. There are approaches to try and strip that away to kind of help you create more malicious content. Or you could take a SLM, something like Mistral or Phi that Microsoft have created, and fine-tune it with a load of malicious prompts and make it kind of like super optimized for offensive red teaming. Now, if you combine that offensive LLM with pair, you could create a pretty effective and pretty powerful red teaming tool. So that is my very quick introduction to AI red teaming and why it's useful to use notebooks for it. Thank you very much. I will have a look at the chat for any questions people might have.
Awesome. I think on the chat, I saw Christian ask you if what is the day-to-day role of the AI red team? Is something special in Pred AI and Gen AI? And what are the expectations for someone interested in this role?
Yeah, that's a very good question. It really kind of varies at the moment. Gen AI is the focus of the industry at the moment, so that is probably where most of our time is spent at the moment. As for what the expectations and skills are for someone in the role, it really varies. I come from a more traditional security background, but there are people on my team who come from a adversarial machine learning background. There are people who come from a like behavioral sciences background. There are people that specialize in social engineering. And the thing about responsible AI and AI red teaming is it requires like a diversity of skills and capabilities and backgrounds and knowledge. So there is no one path in, there is no one thing to know. Obviously, having like a good understanding of AI, particularly, transformer models and how LLMs work is a good start. But really, anyone can kind of get into this space if they want.
Yeah, what I'm hearing from Pete is that, Christian, if you're interested, they got a role for you. Awesome. I think Ian had another question. Is there some generic way of spotting attacks or vulnerabilities in the system prompt? Maybe use an LLM to produce a range of attacks on a system prompt, given access to the system prompts. And he has a bunch of follow-up questions.
Yeah, I don't think there's a particularly great generic way of spotting vulnerabilities in that kind of meta prompt. Quite often what we'll try and do with some prompts is, as part of the jailbreak, we'll ask the LLM to always include a specific, quite rare word in its response, and then we can just monitor the response to see if it includes that word. So again, when we're bulk testing, we'll ask as part of the jailbreak, like, could you include or start every kind of response with the word cactus, then we can just kind of scan for that word. Obviously, that requires the interaction to kind of pick up. The other thing that we have seen is if you look at the logical chain of thought within a meta prompt, you can sometimes identify potential issues. So if you think of a meta prompt, sometimes it's a bit like a flow diagram, like if the user gives you this type of content, do this thing. Well, you can kind of look at that and map it out and see if you can spot kind of perhaps ways that it could be circumvented or, spot the flow patterns that could be exploited to do something that it's not intended to do. So that is kind of one way of doing it. Again, not really programmatic, but one good thing you can look at.
Yeah, sounds good. I guess we can take one last question from Ian. I think he has, do you think it's possible to make LLM secure, or is it just a best effort to try curb the most egregious things?
Yeah, I do, in the same way that you can make pretty much any system secure up until a point. Sure, if you stop anyone connecting or interacting with it, just like a operating system, it'll be fully secure. But as soon as there's kind of a user or some way of interacting with it, you're going to open up issues. I think we can make LLMs as secure as an operating system with the kind of range of controls we have. But as with any security thing, nothing is 100% perfectly secure.
Fantastic. Thank you so much for your talk, Pete. It was a great time having you.
Great. Thanks, Isha.
Of course. Next up, we have Ashwin Patel. He is another very talented security researcher that I had the privilege to interact with in my time here. He has been associated with the Threat Intelligence Center, Mystic, for a decade and has had very significant contributions to the threat hunting, detection, and investigation worlds, amongst many others. I can't wait to hear more about his talk on introducing all of us to the sheer powers of the tool, Streamlit. I'm super excited to learn more, and I will pass on the virtual mic to you, Ashwin. I don't think we can hear you.
Yeah, can you hear me fine now?
Okay. Yeah, absolutely.
I was double muted. Let me share my screen. All right. So, yeah, thanks for the intro. So, I have like very beginner-friendly talk, and then this is something that the issue that we often encounter while working with Jupyter notebooks, investigation, and bringing this capability to the SOC teams, right? So I'm talking about the one of the open source library which makes it easy, and let's talk through like what problem we are trying to solve with the open source library Streamlit. Right? I'll skip the intro. So for the today's talk, I have very few things that I wanted to go over. Starting from like what is the need for the rapid prototyping in security, especially into threat hunting and investigations. What are the current traditional tools that we are currently using? What are their limitations? And then how Streamlit can actually help in resolving that, right? I'll also go through some of the practical use cases where Streamlit can actually help us. And then there's like one small demo that I wanted to show based on the previous work that we have done in the past related to Microsoft Sentinel notebooks, right? So let's start with the need for the rapid prototyping. So it's been so I've been in this information security since 13, 14 years now. And one of the thing that I often regret is about learning the programming languages early in my career, because often you have like these very creative ideas, and then you have to basically work with the team or specific people in order to productionize that idea, right? In a team in a good team environment, it's always easy to talk through, but there are always priorities and other things that comes up which put your the idea, the tool building idea on the back burner, right? So the tools especially helps in a lot many areas. Some of the things that I'm trying to show here is like it will shorten your response time. So some of the like repetitive work that you're currently doing, if you just automate it with the script, that will fast track your triage time and other things, right? There are also no matter like what vendor tools that you're using, there's always some limitations that you will encounter, and then even if you think of like expanding that capabilities, you will often have to fall back to the solutions such as Jupyter notebooks, where you can incorporate multiple things and then try to build up that solution, right? And then once the tool and automation is in place, you can really empower your SOC teams, basically accelerate and remove the repetitive mundane jobs that they are doing, and then focus on the actual threat investigations and threat hunting things, right? So some of the things that I'm talking, we are already solving with the help of Jupyter notebooks, right? So if you have been using Jupyter notebooks, you're well aware of the Python frameworks or data visualization libraries. So there is a wide landscape of libraries that are currently available. Some of the popular I mentioned here is Bokeh, Plotly, Altair. All of these libraries have the interactive visualization component, but then you have to basically render your code with the data in Jupyter or some other environment to make it interactive, right? And then there are always a barrier, entry barrier for SOC teams to stand up a notebook infrastructures if that is not available already, right? Apart from that, there are like standalone data visualization platforms such as Power BI, Tableau. These platforms also have expansion capabilities, such as like you can write some Python code and then hook it up to your Power BI instance, and then you can have like Python library powered Power BI dashboards, right? But again, the code and the complexity is much higher than what you wanted to do, right? The existing log management SIEM tools are also like pretty powerful. They always have like some kind of dashboards, workbook sort of components. But then again, you will always run into like some kind of limitations, right? So whenever there is a need to bring like into your interactive dashboard to the SOC teams, you will always need to know some of the front end knowledge. It requires code and understanding of like HTML, CSS components sometimes to build up that platform, right? There's also like some complexity and overhead that comes up with maintaining that infrastructures. And then sometimes there can be like compatibility issues and other things, right? So let's see like how Streamlit is kind of trying to solve this. And then there are like other libraries I think I've seen which has like similar type of capabilities, but Streamlit has been doing this since over 3-4 years now. And then it has also make this much more easier, right? So Streamlit is basically open source low code Python library. When I say low code, you can pretty much write standalone pages in under 4 to 5 lines of code, depending upon how you wanted to customize those things, right? It has also very modern and elegant interface, so you can share those custom web apps with data science and machine learning capabilities easily, right? So the other thing is like you can also develop this locally and then deploy locally, depending upon the data and privacy issues that you're working with, right? Or if it is something that you want to make it public, you can just host it on cloud or Streamlit community cloud itself, right? Streamlit itself have like a lot of components to make it easier, like standalone widgets and other things. But if you wanted to go beyond the already available components, there is an ability to expand expand and then write your custom components depending upon what your need is, right? And then needless to mention, like with all the AI buzz, there's also like Streamlit has made it easy to experiment and build the AI LLM powered apps, like such as chatbots and other things in very less line of codes, right? So this is you can just get started with like just installing this Python library Streamlit. And then once you, if you wanted to run that web app, you just have to do Streamlit run, and then whatever the script that you're trying to run, right? And then it should be ready to go. Now, as I talked about, some of the use cases that we are currently trying to solve with the Jupyter notebooks are some of the complex data wrangling things, or some of the complicated enrichment and analysis tasks, which is currently not possible through your log management or any other tools. You tend to fall back to the Jupyter notebooks. And then once this data is created and then ready to visualize, that's where like you can put it into interactive dashboards. Right? Some of the other use cases, these are like traditional use cases, such as there is various threat intelligence aggregator feeds, and then if you wanted to visualize those feeds along with the IOCs, that's like one of the common use case by using various API keys and getting that data excuse me, getting that data and visualizing that with the Python libraries, right? Some of your automation I talked about earlier is like any incident investigation workflow, whatever the playbook that you have for any kind of incidents or alert-driven workflows, you can pretty much made it available via Streamlit, right? One of the innovative things that analyst has to do is like when sometimes again, the SIEM tools may not have like built-in ML capabilities and other things. So you have to load your data and then use some of the data science and ML libraries to create and identify some anomalous behaviors and then visualize those anomalies, right? So these kind of use cases, I think you can think of like making it available via the Streamlit dashboards, and then made it easier for your SOC teams to either hunt interesting stuff or maybe accelerate like existing investigation, right? LLM powered use cases, I think some of the ideas that I've mentioned here is like threat intelligence report summarizer or any other video summarizer or IOC extractor that you're trying to do. These are kind of like a good use cases. Chatbots are pretty popular. Again, so many vendor, like including Microsoft, are bringing their own product experiences within the product. But if something that you wanted to customize and then make it very tailored for your specific use case, that is when you have to think about like how do we create and build such an app, right? So let's take a quick look at like the demo use case that I wanted to showcase. So bring my so before I do that, if you have not seen Streamlit, this is basically like how it Streamlit appears. Now this is one of the very old application, like 30 days of Streamlits. Streamlit now allows you to create like multi-page apps, but previously you can just have like a drop down and then navigate to like specific page to load that content, right? So as you can see, like this app is currently hosted at streamlit.app, like a community cloud, and then you can navigate like various components. This is again, this is no different than what your Jupyter notebook is, but the underlying code that's written behind each of these pages is pretty less as compared to what you're doing in a Jupyter notebook.
Ashwin, sorry to storm on stage. Could you zoom in a little bit?
Okay,
With
sure.
the text.
Okay, this should be better. Yep. So the use case that I wanted to talk about, like how we can think of like putting up the existing data science use case into a Streamlit dashboard, is basically anomaly detections using isolation forest. So this is the work that we published sometime last year in February. And then we published like a couple of notebooks, which basically go through, load the data, and then do like some data science workflow, and then use Python libraries to create like to run isolation forest algorithm, and then identify anomalies and then visualize those things, right? So if you're not aware of isolation forest, it's basically this particular algorithm will split your data into two components based on custom threshold, and then it will recursively split until it finds a kind of anomalous data point based on the average path length, right? So this is a tree diagram that you can look. More details is available into this blog post, but in the interest of time, I will not go through these things. So this is basically how the workflow looks like. You have basically logs coming from your SIEM provider. You will do like some kind of data preparation on those logs. Then there is like some data science workflow that you will run, doing like feature engineering, data modeling, and other things. And then after all of that is done, you will run some kind of isolation forest algorithm to generate some score, and then based on the score, you will try to identify those anomalies, right? So all of this code, the underlying code we have published in here. So as you can see, like there are like multiple components in these Jupyter notebooks, and then notebooks for SOC teams is challenging. So this is where we can basically bring in the Streamlit dashboards, where we can have like interactive dashboards to resolve some of the things, right? So this is the kind of like multi-page app that I built, showcasing like data explorer and then data modeling sections. You can also do like data visualizations if you want, but for the sake of this demo, I just wanted to focus on the data explorer and data modeling, right? So as you can see, like this is a Streamlit app. You can expand the layout and other things. This is basically the same project README that I have describing the problem statement and other things. Let's go to the data explorer. So for the purpose of this demo, I just have like a simple file uploader, but again, you can hook it to various data sources, including your SIEM provider. So let's try to load this demo data set and then see like how it looks. So if you have looked into the Jupyter notebooks, one of the things that you often encounter as an early analyst or like Jupyter user, loading the data. Once the data is loaded, if you wanted to do some additional operations, you have to kind of write like custom Python code, right? So in this case, like Streamlit has this custom component, which is like a Streamlit AGG grid. So you can have like this kind of Excel interface within your the web app, and then you can filter out or do like some basic data wrangling stuff within this interface itself, right? So that means that you don't have to write some kind of Jupyter notebooks. Again, some of the similar capabilities are available through within the Jupyter notebooks via panel and some of the libraries. But then this is basically an interface which does not have like any code, and then the user just have to basically use drag and drop and then click through to interact with this particular interface. Okay. Now, the interactive component that I wanted to showcase here is basically this isolation forest parameters. So one of the things that we showcased in the notebook is basically running the data modeling section. So if you're aware of the isolation forest, or any data modeling algorithm, it often has some kind of parameters, and then while working with the exploratory analysis, you often have to tweak this parameter and then try to find out, like, by modifying certain values, how it impacts, and then generates this particular anomalies, right? So in this case, you can have this kind of like slider interfaces, and then you can also select like custom features depending upon the type of algorithm that you're trying to run. And then based on these kind of selections, you will try to populate the anomalies into this another interface in here, right? Now, for the purpose of this demo, I have these anomalies already loaded. But traditionally, based on these tweaking, the algorithm will run on the background and then try to populate the new anomalies and other things. Right? Now, so this is one of the interactive component that I wanted to show, but there are definitely multiple use cases, such as like making it interactive data visualizations and ability to kind of redirecting the same kind of template into variety of data is pretty powerful. And then you can make it, you can really empower your SOC teams to create these generalized frameworks so that they can do this on variety of data. So this was like a quick and short demo. I'll just go back to the presentation. Okay, just a second. All right. So in conclusion, so Streamlit really provides a low-code solution with an open source Python library. And then this rapid prototyping, it can fuel like tool automation idea. It can accelerate your investigation and triage components. And then whenever you have like any data science and ML workflows, you can really bring those innovative methods of detections without worrying of the vendor limitations or doing that from your interactive Jupyter notebooks, right? So with that, I think there are like a few or like multiple resources that you can get started. Streamlit also has like a good app gallery. For each apps, you can just click on the underlying GitHub code and then check like what's going on behind the hood. And then there are also like various Streamlit tutorials that the Streamlit team has published that you can check out to get familiar with that. Right. I think that's about it. So hopefully this was informative.
Yeah, absolutely. I love the presentation, Ashwin. Thank you so much. And thank you for introducing the community to what seems like a really useful tool. I had a few questions for you, if you don't mind.
Sure.
So you mentioned a bunch of really cool practical use cases of Streamlit and security. Which is your favorite one, and which is one that you use the most on a daily basis, especially in the role that you are in currently of a security researcher?
Yeah, so I think undoubtedly the incident investigation workflows. So anytime you can automate the entire investigation workflows and then accelerate like all of your triage, that will basically reduce the overhead and then remove some kind of like a repetitive workflows that team is currently doing, right? So yeah, so interactive components or like interactive reporting and incident investigation workflows are some of the top candidates.
Yeah, that's awesome. And I guess how was the onboarding like for this tool? Like, how much time did you have to spend learning it, and did it differ from the experience you already have versus someone who's more new to the community, like for example me?
Yeah. So yeah, as I mentioned, like I think it's pretty easy as long as you're comfortable with Python. And even if you're not comfortable with Python, I think some of the API documentation that if you start looking at it, those are like pretty well explanatory, and then you can write like very simple components within under like 2 to 3 lines of pages, 2 to 3 lines of code. So it's not like super complicated. So definitely beginner friendly, I would say, which is like under 5-10 minutes you can get app running, and then start building or like customizing it based on your need.
Wow, that's awesome. We love a beginner friendly tool. So you got a lot of love and a lot of conversation going on our Discord, which is open for questions for all these talks, by the way. And Ian had a question for you. So he was wondering if you had time to show a sample of the Streamlit code behind this demo.
Yeah, sure. So let me, I think I should have just go to open here.
Nice.
Yeah, so I think that's a good.
Do you want to zoom a bit? I think it's a little pixelated on the screen.
Oh, okay. I'm not sure if I can zoom in.
I see.
Control plus.
Okay.
That's VS Code. Looks like VS Code.
Okay.
Nice. Okay.
Yeah. So I think so traditionally the architecture is like you have like requirements.txt where you can specify like all of your dependent Python libraries, and then you can have like your the base page, and then you can have like sub pages into your under the pages folder, right? And then whatever the additional like data and images you can put into these folders. So this is like one the main page where I'm just reading kind of markdown file and then displaying with the st.markdown, right?
Yeah.
Yeah.
From a
And
quick
then
view, it's pretty straightforward.
Yeah, some of the other here we have just basically customized these capabilities where we are just reading the files and then using the custom components. These are some of the options that basically have like a drop down and some of the default options that you can do. So yeah, I think the data modeling section is going to be like a little bit complicated where I have like the most of the isolation forest code. But then again, you can probably put this into some kind of abstract library such as Mystic Pi, and then just install and then run that algorithm on those things.
Yeah, sounds good. I think you have a bunch more questions. So the next one is from RPD Sec. Any input on how to deploy tools like this in an enterprise environment? I find this is usually challenging from SSO auth and hosting perspective. Any inputs for us on this?
Yeah. So okay, so authentication is kind of like a good probably something that again I'll have to check through, but the traditional way that Streamlit works is basically once you install this library, you can just host it locally and then basically configure like IP properties and then host it in your local restricted servers, right? So there are like few things that you could do just based on the IP-based whitelisting, which is not recommended. But I think I've seen like some components which provide like a kind of basic authentication and other things that we'll have to check out. But I think something more complicated, such as like Azure AD and other SSO related things, it's going to be a little bit challenging unless you deploy or do like a little bit of customization or digging around it. Yeah.
That makes sense. Yeah. There were a couple more questions in, I guess, two parts. So one, can you integrate Streamlit with notebooks? And is going from code in a notebook to Streamlit pretty simple?
Yeah. So the use case that I showed is basically all of the code that I had in notebook. So I basically pretty much copy pasted the same functions in here. The only things that is going to change is like how you are calling those functions and then assigning it to the variables. That's only kind of like distinguishing factor. So let's say like you want to run this code and then run the isolation forest and then point out those results and then make that results with the widgets. So that's only the customization that you will have to do. But whatever the standard Python code that you have, you'll be able to bring in as is, as long as you have installed those Python libraries.
Yep, that makes sense. Yeah, this seemed like a super cool demo. It seems that, oh, there's another question actually. So you use notebooks to prototype your flow and then Streamlit?
I mean, it depends if you already have done your workflows and ready to go productionize into an interactive dashboard. You can do that. If not, I think you can also start with the Streamlit itself. The thing is that you will have to come back probably to Jupyter notebooks in order to do like some kind of basic exploratory analysis and model building. But once you have like kind of template ready and skeleton ready, that's when like you can just bring those code back to the Streamlit and then make it available.
Yep, that makes sense. It seems like we have some more questions coming in from more people. I see a bunch of people typing, but oh, yep, there you go. No, it's just a comment. Yeah, apparently it's a tool that's already being used in the community, so it's super cool.
Nice.
Yeah. Ian, did you have questions for Ashwin?
I think I was just going to say that you, like you think of Streamlit, from what I know of it, I haven't done much programming in it, but it's like the finished kind of presentation. Unlike a notebook, which if you're doing a lot of code, could be like, I know you can't measure a notebook in meters or yards, but you can get this very, very long experience you've got to try to trudge through. But you can, whereas Streamlit's more a page-based thing. So once you have all your logic sorted out, you can just kind of pile it, like take the Python code, put it in a thing, and I think I'm right. Is every time the page shows, it executes all of the code right in there, so it re-executes the main function. So it's a very simple kind of programming model. I mean, I'm not an expert, but it looks super attractive. It should be. I don't think there's like a convert this notebook to Streamlit. I don't think there's like anything like that. But I think like actually doing that, I don't think it's very complicated.
Yeah. Is it more like Streamlit, or Streamlit is something like Jupyter Notebooks meets Visual Studio Code, like the organization of Visual Studio Code?
I don't know. I think it's more for, like as Ashwin said, you could do your kind of like development, exploratory stuff in a notebook, and but the problem is like, you could like scroll down this long thing. There's lots of cells, lots of output. Whereas in Streamlit, you can organize the output into individual pages. So you could imagine just like what's this user doing Streamlit app? You could have like a page for current logins. You could have like, which processes of the user been on, rather than have to scroll through a notebook. You can just, if that's like 15 cells down, I can just see it on the side and click on it and go straight to the bit that I want. So it's for that kind of presentation, I think it's really nice.
So,
I think we're due for another break. Oh, we've almost run out of break, but we've got a 1 minute break, and then we'll be. I think it's probably almost worth having a break.
Yeah, I think the next talk is at 4:10, so we have 6 minutes.
Oh, right. Okay. Oh, I'll play a bit more music then.
Nice.
Okay, we'll see you on the other side.
Hi, everyone. Welcome back. Me again, not to talk more about red teaming, but to introduce our next presentation. So we have Kai joining us. So Kai works at EY at the intersection of security and machine learning. And I'm very excited for this talk because Kai is going to be covering one of the essential things of security investigation, and that is looking at identity logs. I think anyone who's ever done incident response or threat hunting knows this is always a good place to start. And so, yeah, Kai's going to be talking to us about how we can use notebooks to hunt through and find some goodness in Okta logs. So, Kai, thank you very much for joining us, and over to you.
Thanks, Pete. I'm just going to share my screen. Let me know once it's visible. Okay, I think we'll start now. Yeah.
Hey, Kai, could you make the text a bit bigger? Zoom in a little bit.
Good now?
A tiny bit more.
It's good?
Yep. Cool.
Thank you. Awesome. My name is Kai. I manage applied machine learning research and security engineering for cyber threat management EY Canada. And today I'm going to be talking about Okta. I think most of the organizations have got Okta, and they have pretty good like identity and access management coverage. But then I've noticed that a lot of organizations have Okta and collect Okta logs, but they don't really do a threat hunting on those logs. And they are like sitting in their cold storage or maybe a data warehouse. And this is pretty much one of the reasons I really wanted to do this talk, so that any organization that has Okta and the logs are coming in, either themselves or maybe their managed security service provider can start doing some threat hunting on Okta and start looking at threats from an identity and access management point of view. So today we'll be talking about Okta. Before talking about Okta, we'll try and see the data structure for a typical Okta log, the attributes that we need to understand before actually doing a threat hunting on Okta. So here we go. Guardians of Identity, Okta's Underworld. So I did my imports, and let me read out the definition, what we have about Okta. So Okta is a cloud-based identity and access management platform that allows you to do a lot of activities like single sign-on, multi-factor authentication, and other identity and access management capabilities. Today, we'll be focusing mostly on multi-factor authentication, and our threat hunts are going to be more or less based around multi-factor authentication. So the first step is to get those Okta logs from your Okta server to somewhere where you can actually do your threat hunting. You really don't want to query directly on top of those logs in Okta, but you maybe want to place that in a data warehouse solution or maybe in a database, and then you want to use an API to query that. So what we use here is System Log API from Okta. So this can be used to ingest your Okta logs into a SIEM solution, maybe like Sentinel or maybe Splunk or any other SIEM solution that you might have. If you don't want to ingest that into a SIEM solution, maybe just because you think that I can just get it done with a Jupyter notebook without actually ingesting into my SIEM solution, maybe to reduce your licensing fee or your overall cost, you can use this, which is basically like put that data into a data warehouse solution or a data lake. Like you can use Azure Data Lake or Amazon S3. If you don't want to do that, you can put that into a database like a document store, which is going to be MongoDB. And then you can run your queries against that database or that data warehouse solution to get your results. And one of the best practices that Okta themselves mentioned is don't use the System Log API as a database as a service. This means don't directly interact with that Okta logs or aggregation queries, but maybe put those logs into a data warehouse solution and query that. Now we will take a look at the attributes for a typical Okta log, because these are very important while you interact with the Okta logs. You need to understand the structure of them to make sure that you are looking at the right parameters and the fields. We have some typical ones: the identifier, situ ID. The published is basically the time when it got published. Event types, I think this is one of my favorite because Okta has got some 800 or so event types. And if I open up event types in my other thing here, wait, I can put this out here. Yeah. So you have a lot of event types. Maybe I want to zoom in a bit here. Yeah. So you have a lot of event types in here, and these have got really good documentation. So you can directly look into any event type and read about that from the Okta's blog itself. You have severity, which is basically Okta classifies the login attempt or that particular event into low severity, medium severity, or high severity. And then it indicates whether you want to use an additional authentication method on top of what is already having, or you might just want to go with whatever that is already. Then you have event types. This is the same as the event type. Legacy is just using the old format. Any message actor is basically your user who is interacting with the Okta platform to log into suppose say an application. I'll give you a solid example here. Suppose you have an Azure Ready account and you are trying to log into Office Home application, suppose say. You do your username, password, and then you get redirected to your multi-factor authentication platform. It could be like using any of the MFA. There are multiple third-party MFA providers. You have Okta, you have Microsoft authenticators, you have Google authenticators, you have YubiKey, any other platforms. So it basically like provides that request to Okta, and Okta does your MFA, which is taking your token and providing that token, and then after successful authentication, you just get redirected back to that application. So actor is the user who's performing that action, and client is basically, to put it very simply, client is your device, like the user agent, the OS version, the browser that the user is using. Your request is your typical web request. Outcome is the result of your action. Suppose you have tried to access something, you get an access or you don't get an access. Allowed, deny, fail. These are the typical results that you have. Target is where you are performing that option or action. Suppose I'm an admin and I want to enable MFA for a user. So the admin is the actor, and the user for which I'm enabling the MFA is the target. Transaction is basically your details of whatever action you're performing. Debug context and the authentication context and security context, we'll try to look into this in a bit here, because this is how a typical Okta log will look like in a JSON format. And at first, it might not be very, even though JSON is very readable, but for most people, if you really want to understand the structure of this, I think looking at it in a visual way is a better option. So what I personally do is like use JSON crack, which is going to transform this into a visual thing. So I have my first object here and my second object, actor. An actor has got some parameters in that, which is the ID associated to that actor, the type. Alternate ID is basically the email ID of that actor, and your display name is the name of that user. Similarly, if you look at debug context, you see debug data inside that, and inside you have the request URI. What is the URI which you are requesting to the application's URI or anything? Then your authentication context is more about the parameters that are exchanged during an authentication process here. And this is how a typical Okta log structure looks like. Now that we know how a typical log looks like, let's start with the threat hunting process of this. First, we'll start with the user account hijack. And for this, I'll load up my data set here. For the entire session, I have some data sets with me already, which is available here, like Okta logs. And I'm just going to use that instead of interacting with a database or a S3 bucket or an Azure data lake. The thing that I've commented out here is basically, like if you really want to use your GPU, my data sets are like 100, 300 MBs of data. But if you have a data set like a 10 GB, 20 GB of data set and want to interact with that, it's wise that you use a GPU so that you can perform it faster. You can use CUDA if you really want to go for that. Otherwise, there is this module called Modin, which is a library which is kind of like a faster version of pandas. But for the sake of this session, we'll just stick with pandas, regular one. And whenever I load up a data set, I usually have this habit of looking at the columns of that and the shape of this. So it says I have something around 150,000 rows and 20 columns, and these are my columns. So I have timestamp, I have the actor type, I have outcome.result, outcome.reason. So now we know that what all of these mean, because we have already taken a look at what does that mean in this table. Now, user account hijack, we'll talk about. Okay, so this is more about an adversary or a threat actor trying to take control of your account. So suppose after a successful phishing attack or a social engineering attack, the adversary has successfully tried taken over your account. Now the attacker wants to add the attacker's device as an MFA, because once the attacker has access to you, and suppose there is a logout session or a session like reset, the next time the attacker wants to log in, he wants to make sure that his device is the MFA. So he might want to deactivate your MFA device, or he want to add his account or his mobile device as secondary MFA. So we'll take a look at the event types, which is activate the MFA, deactivate the MFA, reset password, and add a new device. See, if you ever have doubts with any of these event types, the best thing is just copy that, go to Okta, paste that, adds device to user. So it's pretty straightforward documentation here. So what we do is basically take all of those data set in, and then we look for these event types, and then the outcome of any of these should be success. I mean, our attacker should be successfully able to add a secondary device or reset a password, or any of these operations should be a success. And then if you want, you can use this timestamp. I'm not using a timestamp here because the data set that I have here is kind of older data set or a fake data set that I created. If you want to hunt for like last 1 week, you can just uncomment this and that will hunt for your last 1 week of Okta logs. After I filter in for all of those, I want to apply some aggregations. Aggregations in this context is basically grouping all of those events that are filtered out based on those event types. I'll take IP address, country, and alternate ID, which is your email ID. And then I'll take a time frame, which is the earliest time frame here and the last time frame. And then I'll take the unique event types from these and the count for those. How many events in each of those? And then I'll just use a lambda function here to get those things done. And then finally calculating the total number of time it actually took to perform all of those multiple activities. If I run this, I got one user performing 2 unique actions and 18 counts. The unique actions are basically logging in successfully and activate an MFA, and the entire thing took 0.59 seconds. This is based on the data set that I created. So basically the user is trying to do multiple MFA actions in a small amount of time frame, which is not usual in an environment. But again, the threshold that you use here, I use the threshold of 2. You can use a different threshold based on your environment. If you have an environment where this is like a usual operation, then you might want to rack up your threshold. But if you have a quiet environment, you might want to reduce your threshold. So if I reduce my threshold, I can see 1031 rows in here, which is a bit too much. I mean, I don't want that number of alerts or that number of events to do a threat hunt for. So you might want to adjust your threshold based on your environment. Next one is password spray. I think this is pretty straightforward, and a really good thing about Okta is that it has got some inbuilt threat insight detections. So whenever Okta thinks that there is some security threat associated with that, the event type for that is security threat detected. And Okta loves categorizing those credential stuffing, password spray, brute force on its own. And it does a really good job. So if I run that cell, I have 242 events. This time, what I do is I take all of these, which is timestamp, event ID, user agent, country, result. So here you can see that outcome.result reason is password spray, and Okta has already taken care of that deny, which is the password spray attempt from some IP has already been blocked. So this is something that Okta does on its own. But if you want to have a look at the trend of password sprays or credential stuffing that is coming to your organization, you might want to see which location these are coming from, or which user agent these are coming from. Maybe your stakeholders want a fancy graph. You can use this to present that. Suspicious tenant takeover. I'll load my data set here. What tenant takeover is basically, suppose your admin account is taken over by an attacker, and then attacker wants to change, deactivate your user account or suspend your user account. Then you see all of these events. So for these event, this is basically me, an admin or an attacker is trying to do some activities on other users' account. So that's actually like actor performing an operation on target. So I just want to see what a target looks like. And my target looks something like this. This is a dictionary with a lot of fields, but I'm not really concerned about any of these fields. I just want one of this, which is the email ID. I don't want any other fields. So I'll just extract that. Since I have 100,000, it's going to take some time. Oh, it's not good. Here, I have extracted the name of the user, and then I'll see deactivation of that user or suspension of that user account. And if it's a successful activity, I just take the time frame, and then I count the unique number of suspension activities and deactivation activities. And based on my threshold, I'll just output it. So I can see this user, I'll maybe use this one because this looks interesting. 3 deactivated users in a small time frame by this user. But I can actually see that this is an admin account. So if an admin, suppose your user is going out of your organization, changing organizations, new employees, so you always want to make sure that you are like performing these activities. But if an admin is performing these deactivation activities, it's fine. But if it's not an admin, then you have a problem in your environment. Then admin privileges revoked. So here we'll talk about the privileges being revoked from an admin user or the group which have admin privileges. Suppose I got like access to an admin account and just want to make sure that other admins do not interfere with my account. I just want to like deactivate or just revoke some of their permissions. And this is what happens there. I see system at Okta. This is fine if a system is performing these activities, but if it's not a system, then you have a problem here. Then for threat insight, I don't typically see this guy, which is fine. So Okta basically identifies threats, which is like I told in the security threat detected event type. And then this guy says password spray and login failures high. So high percentages of password spray, which are high percentages of login failures resulting in password spray. And Okta has already taken care of this. Then you have session hijacking. Session hijacking comes in when you have successfully authenticated and then you have a session, but someone else want your session token or your session cookie. So if someone else have your session cookie, then that's a problem. And how Okta tackles this is by using something called DT hash, which is de-identification token hash. What it does is basically like gives you a unique token for a session. And Okta typically says that any session should actually be limited to 2 hours. So if someone else, so what this looks for is basically like this token is being used by this user, but this token is also being used by the same user from 3 different locations. At a time, the user is only going to use one country. That's why I use the country parameter here. But if the same hash is being used by the same user from 3 different countries at the same time, that means 2 other attackers have successfully logged into the user account from 2 different locations, which is a session hijacking. And if you really want, that's actually a generic one when talk about just user session. But if you really want to add more parameters into that, you can use this guy, which is the sign on, and then use operating system, browser, and all of these parameters to filter that out. Session impersonation is when suppose the support team or the IT team wants to take your admin access to perform some troubleshooting activities. That's when you give them access to that. That is an impersonation, and usually you don't see a lot number of events for this. And when you see a lot number of events for this, you just have to know that something is going on, and then you try to figure out. So these are the event types that you see, which is an initiation and then granting. If you don't see a grant, only initiation, then someone is trying to get your session. The classic MFA push notification fatigue, which is an attacker try to send a lot of MFA requests, but then the user actually gets fed up of this and accidentally clicks on yes onto one of them. So the event type for that is system push send factor verify push. Then the policy manipulation. Suppose the attacker has successfully got into your account and want to manipulate with the policy, like delete the policy, update the policy, or deactivate the policy, or play with the rules inside that policy, which is deleting a rule or updating a rule or deactivating a rule. Again, you just have to see the threshold according to your your environment. Next one is auth policy downgrade. This is specifically for authentication policies. That happens when a user actually, the attacker wants to make sure that next time they log in, the authentication is actually easy authentication. So they downgrade the policy. And for this one, you just have to look at lifecycle update, rule update, or rule additions. Then you have Okta token manipulation.
Hey, Kai.
Yep.
Sorry, we're running a bit late.
Yeah, it's done. 2 more cells.
Okay.
Sorry. We were talking about token manipulation, which is if this is actually persistence. If I talk about in terms of MITRE ATT&CK framework, so someone is trying to create an API token, or someone is trying to update your API token to have access to your applications. That's when you look at an API token manipulation. Then Okta has got something called FastPass, which takes care of the phishing detections. So if you want to look at the phishing attempts, Okta FastPass is one really good way to look at that. Then something for brainstorming ideas. This is how I created the fake data set. The interesting event types that you actually can see is MFA wipers, admin application access, and authentication via rich client, which is legacy protocol to log into Okta. Then the fun exercise would be like try to map all of these into MITRE ATT&CK framework. Like the API manipulation is persistence, the session hijacking is defensivation. I'll just show you one cool thing about here, which is this guy. If I actually load up my data set from the first one, which is this guy, and then I run this cell, this is basically a community detection. I'm trying to use 2 parameters, which is the user agent and the email ID. So if a user is trying to log in from same user agent more or less, every time you can see there is a community formation. But if it is actually varying too much, you can see outliers. I wouldn't say anomalies or outliers because this is not exactly machine learning. This is more of a community detection. So this typically takes like 40 to 50 seconds to load up. But once it loads up, you should be able to see a really good community here. In the time that it loads up, some references for you guys to actually start looking into. Most of my detections are taken from these references, and really good references, pretty straightforward as well. I'll be sharing my notebook, also the data set in my GitHub. You should be like getting this notebook and play around with that. So this is how the community detection looks like. The same activities are kind of similar things grouped together to make a community. And you see some things which are on the outliers, and you should be only focused on these. You can just change around your parameters to see any of these, but this is how it looks like. And yeah, that's all.
Hey, thanks very much.
Thanks very much, Kai. That was a great presentation. I particularly like the visual representation of the log format you had right at the start. I feel if every log provided that, it would be a much quicker process to get onboarded.
Yeah, I mean, yeah, when you have a lot of data, the easy way to take a look at it is through visualization than going in a tabular format.
Exactly. We're a little bit pushed for time, but there were a few questions in the chat. I think the main thing that people wanted was a link to your notebook and some of the data, if that's available. I know you said you'd post that, so I think people are looking forward to getting their hands on that one.
For sure, for sure.
And thank you very much for joining us.
Thank you. Thank you guys for having me. Bye.
So next up is a talk that I have been looking forward to because it's about something I care about very deeply, which is Mystic Pi. And it's great to have someone who's not one of the main Mystic Pi contributors talking about it. So welcome, Tatsuya. Tatsuya is a threat hunter based out in Japan and is a contributor to many open source projects, including Mystic Pi and the Unprotect project, which I know Thomas on the team is a key part of. So without any delay, I will hand straight over to you to hear more about Mystic Pi and Splunk.
Hello, good morning for me. I'm in Japan. Can you hear me?
Yeah, we can.
Okay, I will show my notebook. Wait, please. Share screen. Okay. Yes, this. Can you see my notebook? Okay.
Yes, we can. We can see that. Thank you.
Thank you very much. Okay, today I will giving a talk opportunity for this title, Comparison of Collaboration Method between Mystic Pi and Splunk theme. Very narrow and very small niche title. I'm sorry. Okay, this picture is explain my title. There are two ways to connect to Splunk from Mystic Pi to Splunk, and Splunk to Mystic Pi. So maybe most of users the above side, but I developed this bottom side technique. So I will show how to do this and later. Okay, let me introduce myself. But Pete made my introduce already, so very shortly. I'm a threat hunter and application developer, and I'm self-employed and mainly contracting with Go Ahead Inc. It is a Japanese small company and log analysis and security consulting using Splunk. And I'm a Mystic Pi lover and contributor. So especially I'm regarding and developing Splunk provider. This is my Infosec career over 10 years, and this is my SNS profile. And I made a presentation of practical Mystic Pi use on APAC SANS DFIR Summit last year. And I really think Mystic Pi is very cool for the data analysis in terms of threat hunting. So I introduced as a reason I use Mystic Pi and Jupyter for advanced threat hunting. It's on my DFIR Summit slide, this one. Okay, so today's agenda is very simple. I explained the way to connect to Splunk between Splunk and Mystic Pi, 1 and 2. And for the conclusion, I'm compared both about advantages and disadvantages with Matrix. First, I explained Splunk query provider and uploader. I'm using Mystic Pi at the latest version this week, 2.10 version. And Splunk query provider has two ways to connect to Splunk. First one is a user authentication. It's developed by Pete. And another one is Splunk token authentication. Is Splunk auth bearer token. It's a kind of JOT token. It's developed by me. Okay, and let me introduce more inside Splunk driver now. Okay, Splunk driver manipulates Splunk's Python SDK to connect to Splunk by REST API. But how can we switch the authentication method? Is a key is a username in your Splunk provider's argument.
His presentation is good.
Sorry. Okay.
Sorry, that was me queuing up something in the background. My apologies.
Okay. Okay, so username is in your Splunk provider's argument. It is chosen the user authentication is chosen with proprietary, and the another is a base of bearer token is chosen. Okay, so and then basically Splunk uploader is using the same trick. It has dedicated class outside query provider like below. But Splunk provider also utilizes Splunk driver for communication. So there are also two ways to connect to Splunk: user authentication and bearer token now. However, there are a thing, the expired check of JSON Web Token has not implemented in Mystic Pi yet. And Splunk app for DSDL, I explained the next. Splunk app for DSDL is Splunk Data Science and Deep Learning, is a Splunk official extension for deep learning. It usually requires external machine resources such as Docker containers outside Splunk application. Data exchange is fundamentally between the machine container and Splunk by using endpoint URLs. Of course, Jupyter Notebook is supported on the machine container. Thus, we can install Mystic Pi in the container side, but it's manually. And Mystic Pi query provider and uploader are not necessary on DSDL platform. The data transfer has done by DSDL architecture. So at first, choose the container deployment that meets your needs. Single instance is very simple. The same instance we has Splunk and Jupyter container, Docker containers. And side-by-side deployment has a Splunk platform instance. We communicate with another instance that serves the Docker and Kubernetes host. In fact, there are also two methods for data transfer in DSDL. Pull and push in container. It's almost same of Mystic Pi's query provider and uploader. Downloaders utilize Splunk REST API, and uploaders utilize Splunk HTTP event collector. And another one, it's very special, listen and return container. It's different from Mystic Pi's query provider and uploader. It uses fit and apply model, and I will explain more later at the next. So if we use side-by-side deployment, maybe there are security data security concerns. However, DSDL has already implemented some data security features. For example, use of proprietary SSL certificate and custom password setting for Jupyter, and fine-grained ACL design with Splunk access token. Splunk MLTK command can interact with containers. So there are two commands, fit and apply. So let me introduce more inside DSDL MLTK containers. So MLTK container utilize endpoint URLs with API auth token for communication, and the API auth token has already implemented in DSDL. So get is a pull direction, and post is a push direction. So I will show a case example and sample code. This is a sample code for PowerShell command line analysis, which is developed on Jupyter Notebook in DSDL machine container. So at first, search in Splunk for the PowerShell base64 encryption string and decode base64 and delete null byte and extract IOC and enrichment IOC and return to Splunk. The black line, this side is by Mystic Pi. However, we have a preparation thing. It's a fit command. Fit command is required the first time for model creation. So the mechanism is originally, this mechanism is prepared for machine learning and deep learning algorithm. So I developed a custom model incorporating Mystic Pi. So when we execute fit command, one Python file is created on Docker container Jupyter side, and the file is consisting of export functions from Jupyter notebook file, which we prepared. And apply side, the Mystic Pi functions is in apply side, and we can see anything to use Mystic Pi, any code in apply side. In other words, I injected Mystic Pi library to DSDL apply mechanism. Splunk's fit command is needed only for first time, and after that, we can use apply the Mystic Pi functions over Splunk without any touch to Jupyter. Of course, we can change the code in the apply function anytime. However, we need fit command, again, to overwrite the Python file. This is a Jupyter in DSDL containers Python file, and it's automatically converted from Jupyter notebook. Okay, let's see the result of this process. This is a Splunk search head screenshot, and the data is Splunk bot with dataset. And this side is PowerShell encryption fit command side. So we can see the base64 string, evil base64 string, and apply side, apply command, and we set this name process base64 IOC enrich. It is saved by fit command into into string. Yes. Okay, so the result is Mystic Pi decode base64 and extract IOC and whois enrichment like this, and return to Splunk. Okay, let's compare the both about advantages and disadvantages with Matrix. The left side is Mystic Pi's query provider and uploader, and right side is Splunk DSDL fit and applies. First, direction. Mystic Pi query provider is Jupyter to Splunk, and this DSDL Splunk to Jupyter. And action trigger, a Mystic Pi code snippet, and this one is Splunk SPL. SPL is a Splunk search language. And secure channel, we have to manage the secure channel by myself or yourselves. However, Splunk DSDL managed by DSDL. So credential management. We manage Splunk credential on the left side, and we manage Jupyter credential on the right side. Next, visualization. Visualization is on Jupyter in Mystic Pi query provider and uploader. And however, on Splunk, only when uploader is used. And right side on Splunk. Next, operation. This is suitable. Left side is suitable for individual analysts, and right side is suitable for team. And next, restriction. Restriction probably no, except for Jupyter machine resource in left side, and probably yes, Splunk could be a shared resource on the right side. Next, advantages. support long-running process and easy for code modification and debug. So, however, because Splunk has a limit to such timeouts, yes. So, and right side, easy to set automatic and repetitive analysis by Splunk schedule search. And then, so disadvantages. Data security concern on Jupyter has the left side, and right side should write more exceptional code for error handling on Splunk. So this is a yes or no for suitable these analysis role. Okay, the last conclusion. My conclusion is very simple and not difficult. For operational purpose, a Splunk DSDL is easy to build Mystic Pi's practical use platform. On the other hand, for manual deep or rapid analysis, Mystic Pi's query provider and uploader can be more useful. And smart threat hunters utilize manual batch and continuous auto analysis. So that is why Mystic Pi users who connect to Splunk may have better know both of these methods. I'm happy if this matrix is to help for them. And finally, comment for Microsoft Sentinel. Probably we will have no worry about the choice for Microsoft Sentinel because it has highly compatible method by using Microsoft Sentinel M machine learning notebooks that uses Mystic Pi's query provider and uploader of the left side of the above matrix, this side. However, it mitigates the disadvantage because all of the components are inside the secure Azure architecture. It's very awesome. Finish. Thank you for giving me this talk opportunity on my son's birthday today. This resource is in public of my GitHub repository. Thank you very much.
Great, thank you very much for such a fantastic talk, and happy birthday to your son. I hope he has a great day today. Yeah, that was really interesting presentation. I think the DSDL is not something I'm super familiar with, but I can definitely see the benefits of being able to have that kind of advanced analysis kind of capability of Mystic Pi inline effectively by injecting into there. I think that's really fantastic. Is there anything you think Mystic Pi could do to make it easier for people to do this, or kind of make it easier for them to add in other kind of features into the DSDL?
It's not difficult, but most of Splunk users don't use DSDL, so the skill is not touched to the using DSDL. So at first, I want to introduce this DSDL mechanism to the junior analyst, and so welcome to DSDL world and Mystic Pi world. Yes.
Nice. Yeah, I see Ian's asking in the chat as well whether he's not super familiar with DSDL either, and so he's asking you can essentially create custom ML models and apply it to the data in the way you would with, say, sklearn.
Mm-hmm.
Is that kind of how you would typically use the DSDL, do you think?
Yeah. Typically, I use for Mystic Pi only.
Okay.
I don't use this for deep learning now because I'm not a deep learning analyst.
Makes sense. Well, I think yeah, DSDL is going to be a new learning topic for a bunch of us.
I just utilize DSDL for Mystic Pi because I'm Mystic Pi lover.
Nice. Well, thank you very much for such a great presentation, and thank you for all your contributions to Mystic Pi.
Thank you.
So next up,
I just wanted to weigh in and say thanks very much
sorry.
as well. That's what you're saying. Very
Thank you. Nice to meet you.
Great to meet you too.
So next up, we have another speaker, Pallavi from Microsoft. Unfortunately, she could not be here today to do her talk live, but she's done a recording for us. So we are still going to get to see the presentation. Unfortunately, not live with any questions. But as way of an introduction, Pallavi is a security researcher here at Microsoft, focused on attack analysis and malware analysis. And her presentation is all about understanding privileges in Azure and how transient privileges can affect the way people access systems within Azure. And I think, again, anyone who's done any threat hunting or incident response within Azure knows how important these privileges are. So with that, we can go ahead and watch Pallavi's presentation.
Today's presentation is Ghostly Privileged, Tale of Transitive Privileges on Azure. I'm Pallavi Jha. This idea was initially tailored in collaboration with Subhash Popuri. The work and the proposal that you are going to see today is basically an enhancement and development on the same. Let me jump onto the crux of this session by asking a question. Is it enough to simply limit access to resources in Azure? Well, the answer is no. Transitive relationships between resources can create hairline vulnerabilities that can be exploited by attackers. Idea is to limit a system where we can automatically identify transitive privileges in Azure. So here we have a notebook, which we are going to go over in a while, which is intended to be utilized for identifying transitive relationships. Well, why transitive privileges? Transitive privileges are often the reason for several breaches, and they don't come out often in straightforward security assessments. Well, that's where the gap is. We can say there are tools such as Azure Hound, which can help us achieve the same. But collecting data and uploading an agent sometimes doesn't work for compliance reasons. Or in plain language, I can say we have found that it's not very flexible like a simple notebook. This dedicated slide is just to highlight our crown jewel, Azure Key Vault. So this cloud-based service, which stores and manages cryptographic keys, sensitive information, certificates, is one of the most crucial and important components for protection. Once an attack happens, it is crucial to get the blast radius in order to do the right remediation in a quicker fashion. So in our notebook, what we are going to do is grab all the required informations from Azure services such as tokens, users, key vault subscriptions, role definitions, key vault permissions, so on and so forth. Once we have them, we are going to find the relationships between them so that it is readily available for the analyst to take an immediate action as and how required. Let's take a look on our notebook. Let's skip to the good part. So in here, yeah, so this particular cell is related to basically grabbing the token from the user using the device code flow. And this is related to getting Azure token. And this is related to getting graph token. Basically, the audiences are different because we are going to query graph endpoint for the list of users, and we will use Azure Management APIs for rest of the stuff. And here what we are trying to do is we are trying to get the whole role definition names if we want to. We can enrich the roles and we can get in the end, but we are not doing it right now, but we are providing a capability of doing so. Here we are getting all the users. And then in this particular cell, what we are doing is we are hitting Azure REST API to get all the resources that are marked as key vaults. Because what are we considering in our demo? Actually, is Key Vault is the ultimate crown jewel that people want to get access to. And that is what we are seeing, that with shadow permissions, this is what can happen. In this, then this is for getting the list of subscriptions. Again, this is hitting the Azure Management REST API. This is for getting a list of keyword permissions, like which user have access to which permission. This is the older version. We are using a newer way of getting it, but this is here for reference for anyone who would want to implement vice versa mechanism. Basically, number of users, which users have access to which keyword. And this piece of code is used to get the managed identity and basically get the list of all MSIs which are assigned and system assigned managed identity. Here we are getting all the resources. This is for getting role assignments for the users, roles for the MSIs. So these were the functions that we had implemented, and here we are calling them. But what happened once is we did not get success with get management identity. We have implemented it, as you can see. But what we are actually doing is that we are using Azure Management API to get all the resources available in all the subscriptions. So here you can see that we have got all the subscriptions and we are passing them here. In here, we are basically iterating through all the subscriptions. And for each subscription, we are hitting the Azure Management API and we are saying, give me a list of all the resources in your subscription and MSIs inherently are a part of subscription management model. So we will get all the MSIs that are part of management of each subscriptions, that are part of management of each subscriptions. Now, in addition to that, we are also considering VMs and logic apps for this demo, wherein this can be used for transitive relationships, meaning that if an MSI is attached to a VM or if an MSI is attached to a logic app, and if a user has access to that particular virtual machine or a logic app, then they will be able to exploit that particular identity, which is already added as a part of this logic app or virtual machine. So what we are doing here is basically that, like from logic apps and VMs, we are checking which all MSIs, which all are the MSIs which are basically managed identities attached to any of the logic apps. Here we are getting all the MSIs and which resources they are attached to. Now, so we are just ignoring any logic app, any MSI which is not attached to any resource. And then we are doing here is we are saying to assess permissions that are required for a user. This part. So that then we are basically doing here is getting the permission that are required for a user. And now starts the visualization part. Here what we are doing is we are taking all the data and we are adding edges. So for edges, let's come to the permissions part here. Yeah. So for the edges, what we are doing is every resource that we identify to be having at least one permission, we are adding an edge for it. No permissions, we are not adding any edges for that. So the idea is for each permission that is assigned to each node, that will be basically be part of this particular graph. So graph here. Now, if you see on the right where my cursor is, this particular node is the keyword, which is the end goal, like the crown jewel. And here on top, if you see, this is the virtual machine, which is basically our virtual machine where an attacker has access to. Considering this user has access to the virtual machine, the user can pivot to this virtual machine, and this virtual machine has eventually has access to the keyword. From there, from here, we can see one transitive relationship. Likewise, we can see another one where this user has access to the logic app, this one, and this logic app has access to the keyword. So basically, there are two transitive relationships, and there is also one where we can see the user is also contributor to the resource. So we can see these transitive relationships, and this all came out from this. There can be more ideas, and we can find more relations for better visibility and display, for better assessment and action. I hope this was helpful. This is pretty much from my side. Thank you.
Wow, thank you very much, Pallavi. I know you're not here, but thank you anyway. Apologies for some of the resolution issues with that video. We have posted a link to the notebook itself in the Discord chat. It is available there, so you can go and look at the details. I think this is a kind of really useful kind of tool to be able to have if you're anyone working with Azure security, because understanding the blast radius and the permissions between all those resources is a complicated thing, and having a nice clean solution in a notebook like this seems like a big win. As we don't have any opportunity for Q&A, we can't do too much here, but I will say if you do have specific questions, please put them in Discord, and we can make sure they get routed back, and hopefully get some answers asynchronously if you do have questions. So that brings us up to our next and final presentation for the day. So the next presentation, I think, is again by someone who a lot of people here will know, which is Thomas. Let me just get you on
His
stage.
presentation.
Hey.
So for those of you who haven't met Thomas, don't know of him, he's part of the Defender team here at Microsoft, but he is also one of those fantastic people that seems to have endless amount of energy and time to contribute to many projects outside. So he's a Mystic Pi contributor. He also is a major contributor to the Infosec project, which is a very cool project that I would recommend checking out. And he's also an acclaimed author with his Visualizing Threat Intelligence book, which I consistently see rave reviews about online on Twitter and LinkedIn. So yeah, Thomas is an all-round expert, and he's here to talk to us about notebooks and Jupyter, obviously. So yeah, Thomas, thank you for joining us. I know you've been working away on organizing the conference in the background as well, so appreciate you taking the time to come front of stage to talk as well.
Thank you, Pete. Thank you very much. So let me share my screen. Okay, can you see my screen? Yes, perfect, cool. So thank you very much for the opportunity again to speak to Jupyterthon conference. I think this is one of my favorite security conference of the world and in the world, and it's always great to see all the work doing by the community. Brief introduction about me. So I'm a security researcher at Microsoft. I created the book Visual Threat Intelligence last year. And you can find some of my work on my website, securitybreak.io, and you can also find me on Twitter. So let's talk more now about the Jupyter universe. So what I wanted to present in this talk is more like a solution or something that we can all use for free and that can benefit to the community. So the question is, why notebooks are great? So we all know that with all the great presentation that we had today about notebooks, we all know that notebooks are great because they are shareable. We can share the work we are doing with other people and they can reuse it. So this is replicable as well. This is very easy to use, like someone will code a kind of a workflow and anyone can reuse it with his own data, change a little bit the code for his own purpose and all that stuff. It's also very actionable because it can help to draw decision and to implement statistics, as we saw today with some of the talk, the one from Colin about ransomware statistics. We also see how to analyze different kind of proprietary protocol with Ismail as well. And there is plenty of use case that you can have with notebook. And lastly, this is also notebooks are also interactive because you can provide different kind of data exploration with dashboards, statistics, and so on. So all of that to say that notebooks are a great tool to share piece of code that can be reusable and replicable by anyone in the industry and for different purposes. Actually, there is any kind of goal that you can achieve with notebooks. Here you have some examples. So notebooks can be used for example, for threat analysis, such as analyzing different kind of data. Can be used for visualization as well, for statistics, for network analysis, for investigation with Mystic Pi, for malware development as well, enrichment. So there is many use cases today that we can use, that we can do with notebooks, and this is great. But there is one thing which is a bit complicated today, is where do I find the notebook? So today there is GitHub, obviously, GitLab also maybe, personal website, the Jupyter Book Infosec repository as well, Twitter. Some people will share their work on Twitter, maybe elsewhere. So it's a bit complicated. Like imagine you have a need, you want to find the specific notebooks, or even all the notebooks that have been shared today. Where should I find them after the conference? So, of course, there is plenty of different links that we share on social networks, GitHub, and so on. But it's not super easy to retrieve the notebooks that we discuss and for specific use case. So this presentation is just all about it. So let me introducing Jupyter Universe. So Jupyter Universe is an application that I created with Streamlit. We discussed about it with Ashwin earlier. And let me show you how it works. So Jupyter Universe is a simple Streamlit application where there is 3 different tabs. So when you go to the home page, you will have some basic statistics. So for now, there is few notebooks available in the database because it's manual and I didn't have the time yet to push all the notebooks that we discussed today. You can see the most popular tags. So obviously it's related to the 6 notebooks. And the day since the project start, and it is today, so this is day 1. You have some distribution because I'm referencing as well the notebooks with different tags. So you can see here, for example, Mystic Pi, Threat Intel, Indicator of Compromise, and everyone can add his own tags. Some distribution statistic as well here. And we also have the top 10 contributors. So for now, as there is not many notebooks in the database, there is only 4 contributors. If you go to search, the Jupyter Universe is basically a search engine where the goal is to index notebooks available by the community. So here you can search for a specific notebook with the title of the notebook, or it can be also a tag. And if you search for, let's say, the Mystic Pi tag, you will have the result here. And then you will have all the notebooks that are using the tag Mystic Pi and that are available in the database. And then you can click on it, and you will be directly redirected to the notebook itself. And then you don't need to spend a lot of time browsing GitHub for specific notebooks, because everything will be indexed into the Jupyter Universe application. So as I said, you can reference a notebook with a name. There is also the author name, and you can also add different tags, LLM, Threat Intel, and so on. So of course, the project is open to the community, and it's super easy to contribute. There is some information here in the contribute tabulation. And basically what you just have to do is visiting the Jupyter Universe repository, and then you will have the information. So what you just need to do is adding this piece of information in the database.json with the name of your notebook, the tags that you want to add, and the link of the notebook. So the link remains yours, wherever you are putting, you are sharing the link on the internet. You can put what you want here. And then the authors, if there is multiple authors, or if you are only one author. And then you just have to send the pull request, and we will review the information, and automatically the database will be read by the Jupyter Universe application, and your notebook will be automatically indexed here. So why I wanted to create that? So basically, I wanted to make accessible all the Infosec notebooks for the community. So I wanted like an open access where you can search for notebook with specific tags, specific authors, specific names, because there is so many notebooks available out there with so many use cases that I'm pretty sure there is one notebook for you. So the goal was really to have something central, something where the community can contribute. So it's you just need to make a pull request to add your own notebook into the database and put the right tags and all the information that we discussed. You keep the authorship of your notebooks, your work, your name everywhere, because the application is not hosting the Jupyter notebook. It's only indexing the information and referencing the link to your notebook. And yeah, as I said, the main goal of this project was to have like a central hub, which is a go-to place for the Infosec notebook community, and where you can find all the notebook that you need. So I hope you like this project. Feel free to have a look. If you have any ideas of how to improve the database as well, because at the moment it's just a JSON file which is indexing. So I imagine that if we have thousands of entries, it will be a little bit more complicated. So I will probably need to move to a database. But I think at the moment it's a great tool, and at least you can use it to reference your notebook and make it accessible to anyone in the community. So thank you very much for your attention.
Great, thanks, Thomas. I think this is a great project. Sharing and finding notebooks has always been the kind of like the biggest challenge, I think, with this stuff, and having a nice repository for it is really good. I think personally, from my perspective, I probably need to tidy up my notebooks and rename them to make them a bit more shareable, because I just have, untitled notebook 31 is my normal thing. But if someone is wanting to contribute a notebook to this repo, do you have any kind of like best practices or guidelines of like what they should do to make sure that it's in the best format possible for both the project, but also other people to kind of then pick up and use?
Well, for this project, mainly, so you just need to reference the link, the author, the name of the notebook, and some tags to help the community find the notebooks based on the tags you put. But more generally, like if you want to, I think notebooks are, as I said, are very shareable. Everyone can reuse them, change the code a little bit for their own goals. But something which is very important when you want to share your notebook is to put as much as description possible, put some comment about your code and some guidelines about how to use the notebook, if there is some library to install. Just make it more easy for the user to, rather than diving into the code and trying to understand, just put some guidelines and description about how to use the notebook itself. And I think that makes the difference. It's not easy because obviously it adds another step of work, when you are working in your notebook, adding more description and so on. But I think it makes the difference if you want to share it with the community.
Yeah, absolutely. And would you recommend people try and share the notebooks alongside data so they exist as kind of like a demo of something, or would you also want people to share kind of like notebooks that could be run multiple times, like more of a template?
Well, that's a good question. I think both of them are useful. Maybe I would say maybe most of the case we are working with some specific data, and if the data are available publicly, then it's probably a good thing to share the data as well with your notebook. But having a template as well for some specific use case, I think this is actually very interesting because that could be a good idea, but I think in practice it could be more complicated. Because having a template, I would say probably the notebook itself is a template, because for maybe 99% of the case, you will have to modify a little bit the code to fit correctly with your own data, what you are doing exactly. So having a template is kind of maybe difficult to have for everyone, but could be a solution to explore as well, yes.
Yeah, absolutely. I saw in the chat as well, Cyber Wardog was asking whether Streamlit will actually render the notebooks as well.
What's the question?
Whether Streamlit will render the notebooks for you.
Oh, okay. So Streamlit is not rendering the notebook, but it's actually a feature that you can add in Streamlit. So there is like a component that you can incorporate to the application. And for example, if you go to the website and click on the notebook, you can render the notebook directly into Streamlit. The thing is, it's probably a little bit more complicated to do something like that dynamically because you will need to install different kind of library in the background. So even if I'm using Docker, it could be a solution, actually. It could be a solution, but it's not as straightforward as it might be. But actually, it could be a good idea. But that means I'm also hosting the notebook on the application, which is not the goal. And I also wanted to say that if you are looking for a place to host your notebook, you can go to the Jupyterbook Infosec repository, and this is a free place where everyone can host their notebook as well. So that's also a good solution.
Fantastic. Yeah. Well, thank you very much. Thank you for setting up the Jupyter universe for us. I'm looking forward to seeing what cool stuff people will share through that in the future.
Thank you. Thank you. Yeah, I hope the tool will be useful for the community. Thank you, Pete.
Very well. Thanks, Thomas. And so with that is all of our talks done for today. And we just have Roberto back to close us out for today. So over to you, Roberto.
Yep. Okay. Let's see. You guys can see my screen. It's about to show up in a second. Awesome. Yeah. So that was amazing. So many different talks, different applications for Jupyter Notebooks. I love to see also some examples into how you can use Jupyter Notebooks for some of the first steps of an idea that you might have for an application, that you might visualize it with something else. And I think that truly paints a picture into all the different use cases, how people are using it, that how dynamic and how adaptive, that technology is, right? How you can use it for multiple things. And every time I think about this conference, I feel that I have seen it all, right? But then every year there is something new, something else that people are doing with that. So yeah, this has been amazing. It always feels like an actual Jupyter marathon, right? Like a Jupyterthon, because there is just so much content. And I like that, there is a lot of different new notebooks that I could also add to my own kind of list of, this could be good to maybe do some analysis with some other different data, but I like the approach of this person that actually did it that way. So that's something that I would like those that attended the conference today and that they feel that they are new to the technology itself. Take some of the notebooks that the speakers have been sharing, and then try to see how you can start adapting some of that to your own things, right? For example, when we started this conference, I just showed a basic notebook with some basic techniques to be able to visualize data sets, right? Just taking the data set of the conference itself, right? There is actually a couple of columns that I would love to explore. Maybe tomorrow I'm going to share a couple of more things in there that it's something that I would do if I'm starting in the field, right? Especially because over 60% of the people that apparently register to watch this conference either online or watch it later, which happens a lot, right? Because of the different time zones and everything. So I would do that, right? For those that are still new, take some of these notebooks and try to adapt it to your own stuff. I also want to say that some of the notebooks that I was seeing and what people were sharing in their presentations, it truly also reminds me of how I do some of my own investigations, right? And how, to me, like how I guess some of you also do your own investigation, where you try to copy a couple of the best Python scripts that you might have to analyze a data set, to maybe so I don't know, visualize the data in different ways, multiple libraries. And you always, when there's an investigation or something that you want to do, you bring all your tools together and you try to just to chain everything together, right? So this is kind of like showing how a lot of people actually work, right, with Jupyter notebooks. All right, so one thing that I wanted to say is, well, first, thank you very much to all the speakers that took the time to join us today and share their research and their knowledge with the community. I also want to thank everyone who was today helping a lot with introducing speakers, all the way to to also helping us a lot through the social media, Discord, etc. Right, there is a community behind it, and I love that every year we're getting more people that are super interested to help and continue this conference. But there is, of course, a day 2, right? Tomorrow, Friday. So if you go to the website infosecjupyterthon.com, you can see first, once again, a lot of information of this conference. If you want a reminder for tomorrow, right, there is a button that is going to give you a calendar invite, right, that you can use, and so that when you don't miss the talks tomorrow, right? So tomorrow starts at 11 hours Eastern time to 16 hours Eastern time. And if you go to the agenda, there is a second tab, right? Friday, February 16th. And we do have an amazing keynote tomorrow as well, similar to today. Like Ryan did a great job as well. So don't miss that one. It's going to be super cool. Always, Leo always has a lot of cool visualizations and a lot of use cases. So don't miss tomorrow. There is a lot of other cool talks in here. And I can't wait to do another day of a Jupyter marathon. So thank you very much all for your time. I hope that you liked all these talks. And I also want to thank once again the whole team behind all this. I really do appreciate your help and your time. And I'll see you tomorrow. Thank you all.